Hello everyone, good morning. How are you all? So I hope every one of you is doing absolutely fantastic. This is your chemistry expert Sanjay sir. I've been teaching chemistry for JEE mains in advance from past 10 years and even more. And I have produced so many good results in the terms of double digit and even triple digit ranks. This year I'm also targeting to grow with this channel, which is our JEE English. So I basically request all of the people to stay much and much more focused, because right now we have just a few months left for our coming exam, JEE main first attempt. For that we are just finishing our complete syllabus. Only a few chapters from organic chemistry are remaining, which I'm gonna to complete in coming 1 or 2 or couple of weeks. So now let us start today's session. We have in the continuity series of our hydrocarbons, we earlier finished apart from GOC, we finished reaction mechanism, then hydrocarbons, and then we have another chapter. Now the organic chemistry of 12th standard we have already started. So what we have today with our the very new chapter called as haloalkane and haloarene, which belongs to class 12. So there is a sequence that will follow in the terms of organic compound, that initially we study about their introduction, their IPSC naming, their kind of isomerism found in them. Then we go through the physical properties of these compounds, their preparations, and then their chemical properties. So this is how a sequence has been built for all the chapters of organic chemistry. Let us start. What is the meaning of haloalkane and haloarene? Before that, let me reveal a very big surprise. On 10th of coming month, 10th of December, guys, you have a big event which will be announced by that time only. There will be so many benefits for all the students. So do notify, go to our JEE Nexus channel and now only just notify this event, which is JEE Nexus. So you can find this event by 7 p.m. onwards. Its detail will be given in our descriptions and the pinned comment also. Now let us start our chapter named as haloalkane and haloarene. Haloalkane means alkanes whenever they are substituted with hydrogen. Hydrogen is substituted by halogen, they become haloalkane. Similarly, benzene or some aromatic compound or benzenoid compound, whenever substituted with halogen, their hydrogen is substituted with halogen, become haloarene. First of all, what is the meaning of haloalkane and haloarene? Let us just understand. So guys, in haloalkane we have Rx as the general structure. For an example, CH3X, CH3CH2X, CH3 CH2 CH2X, so we etc. we term them like chloromethane, yeah, halomethane, haloethane, halopropane, halobutane, like that. But talking about, so we know that any carbon atom which is connected to 4 different groups, 3 are the hydrogen, 1 is halogen, this is sp3 hybridized carbon. Now I'm coming to the examples of haloarene. So guys, sometimes we represent it as ARX, where AR represents an arene. This could be benzene or benzenoid kind of aromatic compound. Let us take this example of benzene itself. So whenever benzene is connected with halogen, and we know that the this carbon is sp2 hybridized, so this becomes haloarene. So that is a difference between haloalkane and haloarene, a common difference between these two. Yeah. Next we have another interesting part of this chapter, which is their classification. So how we classify them based upon the number of halogen atom. So guys, it's pretty simple that there could be CH3Cl is called as chloromethane. It's a mono what should I call it, monohalide or monohaloalkane. Dihaloalkane could be CH2Cl2, tri could be CHCl3, and etc. like that. Okay, CCl4 could be tetra, we can reach to CCl4 as well, carbon tetrachloride. These all are the derivatives of hydrocarbon, and not just the derivative, they are also haloalkanes. Classification number 2 is based upon to which carbon we are connecting our halogen to. Let us take this example. One of them is where carbon is containing sp3 carbon is connected to X. Such type of things are called as alkyl halide or haloalkane. Similarly, if it is connected to sp2 hybridized carbon, it can become vinyl halide. It can become vinyl halide or aryl halide are also such example. So we have seen that your carbon atom to which the halogen atom is directly bonded will be a doubly bonded carbon atom, and like this, take this example. Another example could be, so wherever there is a doubly bonded carbon directly attached with the halogen, such type of examples comes under the category of vinyl and aryl. Then we have simple, the one which we discuss right now. We also have allylic, vinylic versus allylic. So allylic is something where carbon, doubly bonded carbon might be there, but the next carbon which itself is sp3 hybridized, and the next carbon to it will be an sp2 hybridized carbon, doubly bonded carbon, and then halogen is attached there. Such type of haloalkanes are called allylic haloalkane or allylic halide. We also have such example, just like allylic, we have benzylic. So in benzylic, there is a doubly bond carbon. Then next one is also a carbon which is sp3 hybridized, and then we have halogen. Now, if I talk about the hybridization here, this is sp3, this one is sp2, and that is the difference between vinylic versus allylic. Similarly, benzylic versus arylic. Then some of the alicyclic halides are also there. So guys, alicyclic means without any aromaticity or double bond, simply cycle is connected to the halogen. Such type of examples comes under the category of allylic halide. Hopefully this part is pretty much clear to all of us. My notes are very much self-explanatory notes, and that is what I bring with me, that even if a student can read these notes by themselves, right after attending my lecture, you will be pretty much able to understand whole lecture. You can make your own short notes if you want to appear for JEE in 2025. If you are appearing for 26, then you should start making short notes, not just short notes, detailed notes out of this whole content I am providing. And there are plenty of questions here which we can practice. Believe me, this is absolutely enough for your mains and advanced level preparation. Now coming back to one thing, the classification number 3, which is called as based upon the degree of carbon atom to which your halogen atom is attached, or we can also call the degree of halogen over here. So primary is like one carbon is attached to one hydrogen only, so CH2, CH3. Similarly, secondary CH3, CH3, CHX, and tertiary CH3, 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 and then halogen. This is 1 degree, this is 2 degree, this is 3 degree. It's very easy that the degree of halogen or degree of haloalkane depends upon the degree of carbon atom to which the halogen is directly attached with. Take this example, this is your 1 degree carbon atom, this is 2 degree carbon atom, this is your tertiary or 3 degree carbon atom. Now, if you face any doubt, do let me know in the comment section. If not, then let me move forward. It is one of the very easy part of this chapter. Let us come to a question here. Does it belong to the class of vinyl halide? Vinyl is something which is directly connected to a doubly bonded carbon. So now let me check if it is connected to a doubly bonded carbon. Yes, it is connected to doubly bonded carbon, and I can say that yeah, it belongs to the. Oh yes. Okay, give me a sec. I don't know why every time some problem is there. Yeah. It eventually stopped working. Now we had this question with us, everyone. So I'll mark it as a yes, it belongs to directly attached with sp2 hybridized carbon atom. Then we have another question, vinyl. If the allyl vinyl in the halide, Identify allyl or vinyl. Very easy to identify. This is directly connected to sp2. So no doubt it is no. This is directly connected to sp2. This is vinyl halide. And this one is connected to doubly bonded carbon is here sp2. Then we have sp3 and sp3 connected this carbon with halogen. This will be termed as allyl. This is allyl versus vinyl. We have one question here. Nomenclature part and isomerism. Nomenclature part and isomerism. So I'll go in bit faster way because we already have covered this part of nomenclature and IUPAC nomenclature and isomerism in our previous some lectures of GOC. So we'll not take too much of time on this and we'll directly come to the preparation part right after that. We have two type of naming here. One of them is called as common naming. Another one is called as IUPAC naming. We all know how to name it in IUPAC way. In IUPAC way, we take all the halogen atoms as substituent always. That is why we say them haloalkane. Halo is coming first because we are treating all the halogen atoms as the substituents. Similarly, in the common naming, we are treating them like some functional group, and that is why we say alkyl halide. So methyl halide, propyl halide, and like that. Take this example. We have been given up with one of the example is propane bromide. So this N-propyl bromide is the common name, and IUPAC name is 1-bromopropane. Very simple. Similarly here 1, 2, 3. This is 2-chloropropane is the IUPAC name. IUPAC name is the most I must say that most accepted type of naming, very accurate type of naming. So this is something that you have to learn IUPAC. And common name, just take the example, take the idea, because sometimes in your examination a common name can be given up to you and now you need to decide what compound is it. Then in the way your common naming will be in the use. Otherwise, always consider that common naming will not be asked in such a way that compound is given, what is the common name of this compound? No, not at all. But IUPAC naming can be asked. So we have isopropyl chloride here because this is isopropyl group, and this is your what I call it, this is called as secondary butyl. No, secondary butyl is not there. This is isobutyl chloride, and like that. This is enough for JEE mains. Yes, Chandrasekhar will be very right. Absolutely enough for your JEE main and even in advanced preparation. What you need to do is just this whole notes will be enough for your JEE mains, and if you want to go for preparation of advanced, try some more questions, some more PYQs belonging to it, and some more practice you can do it. Else everything is fine for your all the pre-UG journey of JEE and NEET, whatever you're preparing for. We have another common examples of this. If there is like two halogen atom on same carbon atom, we call it geminal dihalide, gem dihalide, and this name is commonly called as ethylidene chloride. Similarly, if it is like 1, 2, we call them vicinal dihalide, adjacent to each other, vicinal dihalide, and then vicinal dihalide are also called as ethylene dichloride. IUPAC is something which we already know about. We can just assign the number. We can call it 1, 1 dichloroethane. So this is very easy naming, right? Now we have aryl halides with us. We usually call them haloarenes, but since there is a common name and where we have to take our halogen atoms as functional group, we call them bromobenzene. Like bromobenzene is the common name and it has been accepted as the IUPAC name also. Bromobenzene, halobenzene is the common name actually. So meta dibromobenzene, we call it 1,3-dibromobenzene. Similar, we have 1, 3, 5 tribromobenzene as IUPAC name. We also call it as like sim tribromobenzene. Sim means symmetric distribution of halogen on this compound. Then we have isomerism. So they can show two type of isomerism. So one of them could be, guys, take this example. Let us say this is a chlorine atom and this is another chlorine atom. Since the number of carbon atoms in the main chain, if the number of carbon atoms in the main chain 1, 2, 3, 1, 2, 3 are same, only the position of halogen is changed here, they are considered as position isomers. Also, let us take one more example. This is 1, 2, 3, 4 and this is let's say this is one more example. So 1 2 3, this one. Now take this example and count the number of carbon atoms in the main chain. So here 1 2 3 4, here 1 2 3. So now these two are isomers to each other, but chain contains different number of carbon atoms. They are called as chain isomers, not position isomers. So this is the difference between Ci and Pi. For more clarification, please refer my isomerism lecture, which I have taught you right after the GOC part as a day 4 lecture. They all are given in the same what I call it, same playlist. You can find all my organic chemistry lectures. So this kind of isomerism is frequently shown by your haloalkanes. Here is a question, everyone. Here is the question: the number of isomers possible for C4H9Cl. C4H9Cl. What do you think? So guys, take this example. First of all, we need to find out whether there is a double bond or not, or there is a cycle or not, or a simple compound is there. Just find the degree of unsaturation. The formula says that carbon plus 1 minus halogen plus hydrogen. Let me just give you the formula: carbon plus 1 minus halogen plus hydrogen divided by 2. So there is no nitrogen, we are not subtracting anything. And carbon are how many? 4 plus 1, plus halogens, hydrogens are 9 plus 1 by 2. So 5 minus 5 is 0. That means there is a simple saturated compound. So how do you can make? So 1 2 3 1 2 3 4 3 4. So now take this example. If in this 4 carbon atom, we can add here, we can add it here. Do we have another possibility? No. So 2 are there. Then we have, this is your let us say isobutane. So in isobutane you have 2 possibilities. One chlorine is here. We have one more possibility, chlorine is here. Do we have another possibility? No, that will become identical. So I think I can see there are like total number of isomers have been asked, but can you see that with one hydrogen this has become optically active? This is now optically active, and optically active will have 2 forms, D plus L. Now this is 2 1 2 3. I think correct answer should be 5. D should be the correct answer. Now if only structural could have been asked, if only structural isomerism could have been asked, we would write the correct answer as C, 4. But now it has been given to us that we are looking for total number of, and since we already have studied about structural and stereoisomerism, we should not hesitate to write down all the possibilities. So I gave you the proper answer here. 5 is correct. Next question. We have 2 bromopentane and 2 bromo 3 methyl butane. Okay, first of all, let me write the structure. Bromopentane 1 2 3 4 5 1 2 3 4 5 6. So just put a BR here. Now it has become what? 2 bromopentane. No. This is your 2 bromopentane. This is 2 bromopentane, and another one is 2 bromo 3 methyl butane. 1 2 3 4. 2 bromo 3 methyl. And guys, it has been asked that what do you think? What the kind of examples are these? So 1 2 3 4 5. So more or less we have 5-membered chain here, 5-membered main chain, and in the main chain of this we have just 1 2 3 4 atoms. Although their molecular formula is same, but they have different chain, they will be considered as chain isomer. A is the correct answer. A is the correct answer. Try this question. You people try this question and let me do. Okay, found it. Fine. Finally, I got it. Probably this is the one I was looking for. No, no, not at all. Mhm. Try this question, everyone. What is the correct for given compound? So this is an sp3 hybridized carbon. This is sp2. This is sp2. This is called as allylic. So the simple answer should be it is an allylic. Also, this is connected to 1 degree carbon atom. So this is also primary. So I think C is the correct answer. Both A and B is correct. किसी ने यार यहाँ से वो निकाल दिया है ना, तो although this is working but this is not working. See, चलो दोस्तों आगे बढ़ाते हैं इस कहानी को. So we have next one is this IUPAC naming. See guys, this is something which we have covered, so I won't go for more and more elaboration here. I'll quickly give the answer and we'll move forward. First of all, we must know what is this structure looking alike. So this is how it look like. This is the way of representation. This is called as condensed formula, and I am writing its expanded formula, a bit expanded, so that I can get to the proper structure from here. So this is how it look like actually. Now you tell me, where can I start the main chain from? This is showing bromine, this is showing what is it, Kyle? This is methyl, but still it is coming at first position. So 1, 2, 3 and 4. So it will become what? 1 bromo, 3 methyl, method butane. Correct answer should be what? And these questions can be asked in your exam, guys. Very good, Chandrasekhar. Keep it up. After completion of isomerism and general nomenclature, we have come to nature of CX bond. So guys, I will explain you this part, that how these compounds undergo substitution and elimination reaction easily. Well, the reason behind is that if there's a carbon chain and then carbon chain is attached to a halogen, so since we know that halogen is more electronegative and carbon being the less electronegative, their shared pair of electrons come nearby to halogen, and then halogen acquires a negative charge, this acquires a positive charge. So what will happen? There is a possibility that if a negatively charged species attacks, on this substrate, it will go to the positive charge center and then it eliminates out the chlorine, and this becomes SN reactions, nucleophilic substitution reactions. So this is what we will study later on. So it's a polar bond actually, okay? We can say that dipole moment is node 0 mu net, and these are polar molecules, polar compounds. Next, we have bond parameters. If we talk about, guys, sometimes questions have been asked. These questions might belong to chemical bonding, but believe me, these questions have been asked previously so many times, and the most important out of them is the bond length parameter, because we usually see that bond length should be higher for methyl iodide and then it should go on increasing down the group, but it doesn't happen like this. And there is something which we are for. No, it's not bond length, it is actually dipole moment. Bond length is like something which keeps on increasing down the group. Check it out, bond length is increasing down the group, 139, 178, 193 in this. But the CX bond enthalpies are this, which also keeps on decreasing down the group. Definitely it will decrease because Bond formation between 2p will be of highest energy and of highest stability, would require more energy to break it down. And then we have 2p 3p 2p 4p 2p 5p. But coming to this, dipole moment is actually the product of two parameters. One of them is charge, another one is distance. So charge into distance will be highest for CS3Cl, because the charge might be even more in the case of CS3F, but the distance, because it's very less, as you can see 139, exceptionally smaller, that is why its product becomes lesser than chloromethane. So correct order, you must know that the correct order is CS3Cl will be having the highest, followed by your CH3 fluoride, followed by CS3 bromide, followed by CS3 iodide. This is the order of dipole moment mu. Hopefully this part is absolutely clear to you all. So guys, those who are watching this lecture, do like the session. Everyone, keep on liking the session. Next we have why is it not working? I'll break it here. Anyways, in the presence of electron rich reagent, there could be two things which can happen, which these two are called as the characteristic reactions. These are called as the characteristic reactions of haloalkane. Why am I calling them characteristic reactions? Because as you know that this carbon halogen bond is polar. The substrate can be attacked by a nucleophile directly on the carbon, or sometimes to the alpha hydrogen as a base. If attacks, some base attacks on the alpha hydrogen, it leads to the formation of an elimination reaction, and then alkene comes as a product. So this is what the major reactions are, which we'll study in the chemical properties of haloalkane. One of them is substitution, another one is elimination. And the good part is, this is something that we have already covered in our reaction mechanism lecture. So those who are understanding, those who are facing doubts in understanding the mechanisms of the reactions, do watch that video. Everything is available in the single playlist. You can directly go to my GOC or organic chemistry playlist, find the chapter 3rd or 4th is there with the name of reaction mechanism. There I've explained every single part relating to your substitution reactions, elimination reactions, everything. Now we have nucleophilic substitution reactions, and reaction mechanism is something which is already covered in the SN reactions. I told you four type of reactions in fact: SN2, SN1, SNI, and SNNGP. So guys, something that whenever the reaction will come, I'll explain them once again. So don't worry, just try to learn and just take these things in your mind, that how many types of eliminations are there, and all of these are actually, guys, called as E2 elimination, not E2 elimination. We call them beta eliminations. They all are beta eliminations, or sometimes also called as 1,2 elimination, because their major product will be alkene. We call them 1,2 eliminations because their product will be alkene. Otherwise it could be a carbene, somewhere it can be a cyclic part, so cyclic chain sometimes somewhere is formed. But anyways, we know that elimination or 1,2 elimination, beta elimination will be taking place in such case, forming alkene as the major product. Then we have elimination reaction. What did I write? Eliminations is here. That is not elimination, that is simple substitution, and this is the elimination part, and they will lead to the product of alkene. They will form alkene as a major product, and this is all working on beta elimination or 1,2 elimination. E1, E2, even CB, EI, this is all we'll cover in this chapter, don't worry. where we have a question, which of the following has the higher dipole moment? And we all know, because of the charge multiplied by density, this distance between these two ion or atoms, we have CH3Cl highest in the whole halomethane series. Why methyl fluoride is less reactive than methyl halide? Tell me. Why methyl fluoride? Because guys, you know what, CH3F, we all know carbon belongs to 2p, so there is a 2p strong covalent bonding between carbon and fluorine, so it doesn't allow methyl fluoride or any of the alkyl fluorides to react very easily because of this strong bond of carbon and fluorine. It doesn't get break easily, and that is why it's not very easy to it shows lesser reactivity. Another question here, the bond enthalpy, we go down the group, bond enthalpy decreases because on moving down the group, the strength of bond decreases. Initially you had carbon fluorine 2p2p, carbon chlorine 2p3p, then carbon bromine 2p4p, and then carbon iodine 2p5p. As we going down the group, extent of overlapping decreases, bond strength decreases, and bond energy also decreases. Tell me the correct answer. I think D. Without any confusion, I'll pick D as the correct answer. Another question is here that allyl halide show two characteristic reactions, SN and elimination. Why? Because of the polarization of carbon halogen bond. Yes, and X is generally a good leaving group. Also, that is also a good part because halide is a good stable leaving group, and due to which it can lead you to the formation of your respective product, either it is going for the elimination or substitution. So I guess D is the correct answer, and C is incorrect because this is a polar bond, and carbon halogen polar bond makes the whole molecule as polar. It is non-polar. It is incorrect, written down in the C option. Let's go for the preparations of haloalkane. Now we have come to their preparations. So let us go from hydrocarbons first. Number one is from hydrocarbon, alkene alkyne. So how do we make this? In hydrocarbon chapter, I have already covered this part, which is called as free radical halogenation of alkane. You remember chain initiation, chain propagation, chain termination. This is what we followed. So won't take too much of your time. Simply the rate of reaction will be F2Cl2 Br2I2. Why? You might be wondering, or you might be thinking that, sir, the bond strength between fluorine is highest and then followed by chlorine, bromine, iodine. But no, it doesn't work like that. Actual reason behind is that free radical formation is pretty easy right after the addition of the chain initiator. All the radicals will be formed. Now those who can directly react with the carbon chain and can form a carbon halogen bond, their stability and that amount of energy which is released will decide this particular reaction. That is a free radical addition reaction, and also called as free radical substitution reaction. And this reaction is also that part of addition of the halogen as a radical is also the slowest step and RDS of this reaction. So guys, take this example that fluorine is violent and explosive reaction, iodine is very slow and reversible. So very simple reaction is here. I will give you one important part here without disturbing whole things. We already have covered this part in our previous chapter of hydrocarbon. So everything is connected. Those whoever are starting your 12th standard preparation, they also should start it from GOC, because organic chemistry is something which is pretty much connected in terms of every chapter. I would like to suggest you that you must start it from the GOC, followed by your hydrocarbon, followed by your reaction mechanism and all, and then come to this haloalkane, haloarene. So take this example that whenever we are given with methane and some chlorine has been added to it, and let us suppose the chlorine is in excess. If chlorine is in excess in the presence of sunlight, this will give you CH3Cl plus CHCl2, CH2Cl2 plus CHCl3 plus CCl4. All the products will be there, and there's a like mixture of product, mixture of different products you will get, substituted products. But if you are taking methane or the substrate as an axis, Chlorine is limited and H nu. Majority of the component will be mono substituted or monohalide will be there. So this is an important part which I told you. The very important part is here. We have another reaction called as halogenation of alkene. We also have covered this part, and if you remember, I told you two things there when I was teaching this part in hydrocarbon chapter. I told you two parts, that one of them is car and the another one was tram. The car means cis alkene on dihalogenation in CCl4 will produce you, if there is a symmetric alkene, we have cis symmetric alkene, then you will be getting a racemic mixture. Racemic mixture. And if it is a tram, means trans alkene is there with symmetricity. Trans alkene, a trans symmetric alkene on combination with Br2 and CCl4 will give you a meso compound. Meso compound will be produced. So that is an important part of this reaction that I'm telling you. And why am I not just over elaborating it? Because this part has been already taken cover under hydrocarbon chapter. That was our previous chapter. So believe me guys, everywhere you'll find some topics which are absolutely connected to each other. So you all must go in a proper sequence. You all must follow a particular mind map, that till here we have to study this chapter, then followed by this, and that will definitely help you to understand the complicated part of chemistry, which is your organic chemistry, easily. Just always follow a proper sequence. That's what it needs. Yeah, I'm finding and I'm not getting it. We have a question here. The most reactive alkene with Br2CCl4. Now, what do you think? Which alkene should be the most reactive alkene? Let me just give you this idea that CH2, okay, let's say if I'll show you the mechanism, you by yourself will come to know, okay, this is how it happens. It forms a cyclic halonium cation. Cyclic halonium cation, and the next attack of Br minus will take place on that carbon which is more substituted, because that will be having more stability of carbocation over that. More substituted carbon this attacks upon. So what we are basically getting here, this is your slow step or RDS. This defines that higher is the group present, more substituted, alkene gives more stable cyclic cation, because guys, this cation is actually what I must say, this cation is actually stabilized by the and it is distributed this positive charge over all three members, and the one which is having higher groups will more stabilize this compound. So Cr2/Cr2D is the correct answer. Initially we were thinking that CH2 must be the answer, but no, logically if we go and if we find the RDS here, the correct answer should be D. Next chapter will be alcohol phenol ether. Right after this chapter we are following the 12th class organic chemistry. Right after that, aldehyde, ketone, carboxylic, everything will be covered guys, don't worry. Come to this another equation called as halogenation of alkene, which is X2 in water. So you must know then X2 in water produces X2 plus water. It usually this X2 could be Br2 oblique Br2 oblique X2, sorry, Br2, Cl2, Br2, I2, all of them combines here and form HOX. The most important part is this, which stays there like H positive and no, X positive and OH negative. So this is what it does, the Markovnikov's attack. Follows the Markovnikov's addition. Since this part is already been covered, I'm not giving you too much idea because we already know about it. This is something which we have covered in our previous chapter, hydrocarbons. Now take this example. Let's say we have an alkene here with us. So guys, let's say I'm giving you an unsymmetric alkene and we are reacting with bromine and water. So bromine water will form what? HOX, and HOX has X positive, Br minus. First attack will be taking place on like Br positive. So how does it look like? This is how it works. Br positive. So this is attacking like this. This is positive charge. In the next step, water will attack and hydrogen will be departed, and this forms CH3, CHOH, CH2Br. We call this reaction, although anti-addition takes place in all the cases, but most importantly, what we find is most importantly that Markovnikov's addition takes place here. हेलो यार, ये मेरे साथ ऐसा क्यों होता है पता नहीं। क्या हो गया? अब मैं यहाँ पे वो जो हमारे पास रिमोट होता है ना इसका, yeah, probably. Actually, some problem was going on related to this remote, guys. I just have fixed it. See how now it is working. If anyone faces any doubt, do let me know. This part of like electrophilic addition over alkene has been already explained by me in my previous chapter called as hydrocarbons. So I am just explaining this in a bit faster way, because believe me, this chapter is exactly very huge chapter if we go through every single topic and explain it in very detail. Because what happens, everything in organic chemistry is pretty much connected. Whatever you have studied in hydrocarbon, there were some chemical reactions of alkenes we study, and the reaction were giving product as the haloalkanes. Now in the preparation of haloalkane, the same reactions will be used. So we are just repeating everything. So since we are repeating it, we'll quickly give an idea how does this reaction go, and we are not supposed to rote learn the mechanism part and all. Believe me guys, if you want to crack your JEE exam, just try to make short notes. You must take this idea that what kind be the reactant should be there, what kind be the reaction attacking reagents are there, and what is the final product, and how does final product form, that you must know. That Setzef alkene will form, Hoffman alkene will form, or that is what we know. There's no requirement of rote learning all the mechanisms in chemistry, because it's not even possible to rote learn on all the mechanisms. So that's how we do. Then we have another reactions, guys, hydrohalogenation. We also follow the Markovnikov's addition here. The meaning of Markovnikov's addition is pretty simple, that if we have an alkene which is unsymmetric, and let us suppose I am reacting this compound with HBr, it will form that hydrogen will go to more number of hydrogen containing substance, bromine will come in the center, or will be attacking where more stable carbocation is there bromine ion will attack bromide ion. But let us suppose if you are bringing peroxide in meanwhile, this is called as Kharash effect, I told you, or anti-Markovnikov's addition takes place here, and then it forms CH2 and CH2Br. What it is following? This is following now anti-Markovnikov's free radical mechanism. This is Markovnikov's addition. Now take this idea, write it clearly, and I'll move forward. Next is hydrohalogenation of alkenes, and addition of HX is there, which we have already covered. Then we have preparation of alkyl halide in laboratory is least preferred by direct halogenation of alkenes. Are you sure or not? Because yes, this is absolutely correct, because we already know that there are multiple reasons that if we have been given up with CH2, CH2, CHCl like CH3 and CH3. So guys, if you are reacting with chlorine, so there could be possibility that CH2CCl CH3 plus CH3 CHCl CH3 there is a possibility that CH2Cl CH2 CH3, that's like what we can say is mixture of products. And since we are getting mixture of product, the yield is not too much and we are not getting our selective product, and that's why we reject this process of preparation by directly halogenation of alkane. We have to ignore this process because this produces plenty number of products which are not of our use. We needed just one. Another question over here is that why the order of reactivity of halogenation of alkanes is this. I told you the formation of carbon halogen decides this formation of carbon halogen bonds, stability, rate of reaction is direct relation to the stability of carbon halogen bond. Why bromine and iodine are more selective in chlorination? Because the rate of reaction is bit slow and there is enough time to prepare the required product. So guys, that is what I'm saying, and this selectivity has been already explained by me in the hydrocarbons chapter when I was teaching you the reactions of alkanes, especially the halogenation of alkane. So let me explain it like in a theoretical way. What is it saying? It is saying that whenever we attack with bromine or iodine in presence of some sunlight on alkane, then you will get that 3-degree product will be in highly yield because the reaction is slow. Reaction has enough time to think where can become the most stable radical, there will be the attack happening. But in case of chlorination, the reaction is very fast, this much fast that whatever the radical is available there, irrespective of that radical is getting converted back into 3-degree, it will directly go on all the radicals possible. They will form 1-degree also, 2-degree also, 3-degree also. Although 3-degree will be the major product, but still there will be a significant yield of 1-degree and 2-degree also. So that is what happens in the case of chlorination. That's why we say that bromination and iodination are the most preferred way or most selective way where we can get the selective product. Why addition of iodine to alkene is a slow reaction? The same reason is here, that carbon iodine bond has less stability, has lesser stability. How many monochloroalkanes can be possible by chlorination of 2-methyl pentane? So let us say this is an example. We have 2-methyl pentane, and how chlorination product we need to tell. So what do you think? One can be connected here, 2, 3, 4 and 5. So 5 products could be there, but we must know that which of them can be optically active. So something connected to this part will become optically active. Rest, I don't think anything is optically active apart from this. I think correct answer should be 6, because one will be optically active. You must remember this part, that not only structural, you also see the stereo part. So 1, 2, 3, 4, 5 are the product, but the fifth one has 2 D plus L. That's the total answer will be 6. Next question, isobutylene on reaction with chlorine gives chlorine water. So what do you think? Okay, we have gravity with us, high gravity, and gravity you gave the correct answers for the previous question. Now take this idea that isobutyl, what is the meaning of butyl? This is called as isobutylene group. Methods pro butene, but with a double bond will become butane with double bond butene, and isobutene is called as isobutylene. So we are getting it reacted with Cl2H2. As I have already told you guys, this means there is some reagent of HOX. Don't get hesitate to write it like HOX, where HO will be minus and X will be positive. Now electrophile is X. So what will be the product? The Markovnikov's addition will take place undoubtedly. More substituted will be acquiring the negative charge species, because there will be stable carbocation. This will be acquiring positively charged species, which is Br, not Br, Cl, and this will be having OH. Now please check your answer carefully, where you can find this combination. Cl attend Ba, zup, 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 zup. Where is the correct answer? Yeah, I think none. No, here it is. A is the correct answer. We have next question. What will be the product in the following reaction? Now what is NBS? Guys, NBS is called as N-bromosuccinamide. N-bromosuccinamide. What is a succinic acid? Ohm's gap. Ohm's gap. Guys, this is called as NBS, which easily dissociates, giving you free radicals. And this free radical basically acquires easily hydrogen is being acquired by this compound, and then Br radical attacks over what I must call it. So this is like free radical is coming here and attacking on more stable radical. Can you find here can be the more stable radical? So this is how it is formed, a free radical, and with the formation of succinamide. This succinamide is there. Now this compound will now later on be reacted by Br radical, and there you get your final product as Now tell me, where is the correct answer we are getting? NBSN bromosuccinamide. C is the correct answer. We have one more interesting question that came back in 2020. Okay, JEE 2024, only this year this question has been asked everyone. I must see how many of you are pretty much able to solve this question with me. Sir, chemistry इतनी tough क्यों होती है? Chemistry is very easy, यार. Chemistry is not too tough, guys. The only tough is our way of approach. If we do not have a proper way of approach, then we face the problems. Yeah, now coming back to the next question. Okay, nobody has submitted with the answer till now. We have been given with an chloro, what do we call it? Chloro, no, it's toluene. So toluene, on reaction with this, we have to prepare a mono halo product, and that must be, no yaar, we are not supposed to make the mono. The only stable free radicals will be on the carbon atom. So CH3 on reaction with Cl2 and H nu, and this will give you a compound which would look like CCl3. So let us say we are using 3 equivalents here. We are using 3 equivalent and minus 3 HCl will be there. So now what you need to do is, we are hydrating it using H2O. So this H2O will replace all of these 3. Cl will form a compound which look like this. OH, OH and OH, and you all know that 2 OH groups on one carbon atom is highly unstable. It eliminates out water in it, forming a C double bond O, and then your final product will be COOH. Now you have made a carboxylic acid out of it. This is called as benzoic acid. Tell me, where can you find the correct answer here? The very first product that we made was, actually I found nowhere the correct product, because see what is happening is, we must take this idea from A. We should take the idea what A we are preparing, and then what can be the further product. If we are not getting this in either of the situations, so cut it out. We can get CHCl2, and then we can get B is also correct, because if there will be only 2 Cl, then 2 Cl will form 2 OH, and then water will be eliminated out, CHO will be formed. If we have CH2Cl, only one is there, then this is incorrect product. In that case, this could have been your product, an alcohol, CH2OH. Only the Cl part is replaced by OH part. So that is how I think the correct answer should be C. You must be thinking that why did I actually went for this? Why am I using this example? I tried converting all the possible hydrogen into chlorine by substituting all 3 hydrogen, but in this question we have to identify A first. So A is not the correct option. B has to be basically picked up as an option. A is something which is given to us. So let us say if 2 hydrogen atoms have been displaced, then it will form CHCl2. Right after addition of 2 OH group, which is not as stable, water will be eliminated out, C double bond will be formed. This is correct answer. I think B is the correct answer. Moving forward to another reaction is called as halogenation of alkyne. So halogenation of alkyne will give you tetra halo products, guys. Tetra halo products, as in and so same anti addition takes place. As I told you, this process takes you to anti addition. The mechanism itself suggests us, once there will be a cyclic halonium ion, another attack takes from opposite side of the halonium ion and the departing group. So this is tetra haloalkanes are formed. Then we have the reaction hydrohalogenation. Hydrohalogenation will be like double hydrohalogenation, guys. Why am I calling it double? Because we are using now alkyne. These reactions have been already covered by us in our previous chapter, hydrocarbons. So this is something that we already know about. You want to give me an example? I can prefer one example, and that too we should take unsymmetric alkene, so that we can reach to the particular mechanism and particular answers. Let's say we are using two equivalent of HBr. Marconi-Cos addition no doubt will take place. The addition will be occurring in such a way that more stable carbocation will acquire bromide ion. So CH, we have one Br here, we have another Br here, and then we have CH3. Okay, mistakenly I this will be C triple bond CH. Now it is fine, because now we are using two equivalents here. And the same thing which we can do is let us say we are using peroxide, Kharash effect will take place. Two bromine will attack on the same carbon, the terminal one. Halogenation of alkyne, and then we have addition of hypohalous acid. We all know about it. Yeah. Hypohalous acid is like say Br2 plus H2O. We have to make the HOBr, Br as electrophile, OH minus as the nucleophile. How this reaction takes place? Let's see. Same Marconi-Cos addition will be there. Br will be attack, Br will take first attack, and let us say we are using two equivalents. So how does it work? CH, we have OH here, and we have CH Br here, but we all know this is unstable. This unstable molecule will eliminate out water and will form the final product as CH3C double bond O CHBr2. So in case of such compound like aldehydic or ketonic group is there, you can prepare such compounds using this reaction. Aldehyde and ketone session will be right after alcohol, phenol and ether, which will be definitely covered in upcoming week only. Probably on Friday or on Saturday we can plan this session on upcoming one, because the only chapter which is in between right now is alcohol, phenol, ether. So I have given you the exact idea. You can read out the notes properly, and you all know that one short series which I am bringing, I'm giving you complete information. Wherever you find that I'm not providing the complete information or complete in-depth knowledge, that means I must have given that part in the previous sessions. So believe me everyone, this is a pretty much connected series of organic chemistry. Those who find difficult to understand in this entire organic chemistry, first of all, you must visit my general organic chemistry lecture, where in the basics of the organic chemistry have been revealed to you, writing the IUPAC nomenclature, knowing about the degree of carbon, hydrogen, halogen and their classifications, and then right after that we reach to the electronic effects, then their applications, then acidic basic strength, and then stabilities of carbocation, carbon and free radical. Then we reach to the reaction mechanism part, understanding what is a solvent molecule, how many type of solvents can we take, what is an electrophile, what is a nucleophile, what are their classifications, what kind of reactions have been given by alkyl halides, which are characteristic reactions of substitution and elimination. Then we reach to hydrocarbons, where I completely went through alkane, alkene, alkyne, their preparation, their physical chemical properties and their preparations. And right, the same portion and the same repetition will be followed in upcoming chapters like alkyl halide, aryl halide. We'll first of all understand their introductory part and IUPAC nomenclature, and then we'll go to their preparation, which we are right now doing, then reaching to their physical property, and right after that we'll be having the chemical properties or their chemical reactions. So believe me, this whole series will be followed in such a way, but wherever you find that you are not able or I am not providing you the enough information on that, that means you have to visit the previous lectures in order to cover the whole part. Like you can see in the all alkyne and alkene, wherever we are preparing the haloalkanes from alkyne and alkene, this part has been already covered in hydrocarbons, where hydrocarbons had the chemical properties and the similar reactions were there. But still we're taking the idea in the good way. Thank you. Okay, now let us move forward. Addition of HCl to ethine takes place according to Marconi-Gauss rule. Yeah, true. What would be the expected product of the reaction of propyne? What is propyne? CH3C triple bond CH. What we are attacking it with? Br2H2O if the mechanism of this reaction. So Br2 H2O. You guys all know about it. This forms HOBr. And in order to carry out this reaction, we need two equivalent. So the product will be CH3. C will be having a positive charge to twice and two OH molecule will attack. Similarly, CHBr2 will be here. We all know that water on OH molecules on two OH molecules on one carbon atom is highly unstable. It eliminates out water immediately, forming a C double bond of bond. So correct answer will be CH3, C double bond O, CH2, CHBr2. Please find out the correct answer. What do we call it? Write down the IUPAC name. 1, 2, 3. So 1,1 dibromo propanone. And I personally think that guys, they are not reacting with two equivalent, they are only taking one equivalent. Let us suppose we are taking one equivalent, don't worry, we'll produce the final product. If one equivalent has to be taken, let us suppose one equivalent is there, Br2 and water mix is giving you HOBr, one equivalent, and then one equivalent will produce a product of the more stable carbocation will get the negatively charged particle, and the more lesser stable one will be getting the, not lesser stable, the another one will get the hydrogen. So hydrogen, instead hydrogen we have this electrophile of Br positive. That is how the product is formed. Now can you write the naming of this compound? Yeah, I can do it. 1, 2, 3. So 1 bromo propene 2-ol, 1 bromo propane 2-ol. Well, there are so many names are there. 2 bromo 2 propanol. Bromophenol, no yaar. Bromoacetone can all be the correct, but 2 bromopropanol, I think this is correct. No. I think I didn't find any of the correct answer here. Pardon me everyone, I couldn't find any of the correct answer here, but if you find it, do let me know. No option is given here. Anyways, let us move forward with another question. What will be the major product of ethine reacts with chlorine in water? Yeah, the same question is here. CH double triple bond CH, it reacts with Cl2 and H2, and we all know that what does it make? HOCl, where Cl has to be taken as positive, this has to be taken as negative. The first attack takes place of Cl plus. Let me explain you the mechanism also. So the first product will be CH triple double bond CH, and it will be connected to Cl with a positive charge on this carbon. Later on the negative charge species will come and attack, and then it will form CHOH and CHCl. But now there is one more thing that can happen, that let's say we are using one more equivalent HOCl, this can also attack and can form CHOH and OH, and this will become CHCl and Cl. But the question says that this will be unstable and eliminating out water. So after elimination of water, this is your final product, C double bond OH CHBr2, oh, sorry, Cl2. So correct name will be 1 2. So 2,2 dichloroethanol. D is the correct answer here. Now you can prepare whatever you want. You must know the nature of reaction. So that is how I have advised you all, that always whenever you go for the preparation of notes, follow a particular sequence. That short notes preparation must take in such a way that what is the reactant, which particles or which chemical molecules can react here, what reagent has to be used in this reaction, and what is your final product. If you can remember this in a particular sequence, believe me, you will be very much comfortable doing your organic chemistry preparation. Next, a question, similar question was asked back in JEE Main 2024 this year itself. The question says that propanol on reaction mentioned is, okay, the product CVO to tell, this is Br, this is alcoholic KOH. Well, this reaction is actually elimination. So CH3 CH2 CH, no, this will attack on this hydrogen, eliminates out like this. So CH double bond CH2. Then we are reacting it with HBr and it produces CH3 CHBr CH3. Then right upon heating it with KOH, no, not heating it, aqueous KOH is there, or you may heat, but there is aqueous KOH. So aqueous KOH is, this was an alcoholic KOH. Alcoholic KOH works as a base, and aqueous KOH work as a nucleophile. So this nucleophile will replace CH3 CHOH CH3. This is your final product. What do we call it? 1 2 3 propane to all. D is the correct answer. See guys, how easy questions have been asked in JEE exams. I personally find these questions pretty easy, and even you can do the same with me. Correct? I hope I'm pretty much clear till here. Now let us come to the next mode of preparations of haloalkane. We have another reaction from alcohol. This is also very important part, that from alcohol we can synthesize haloalkanes, and how that we'll know. So guys, there are two reactions that I want you people to understand, or I can write it by my own also. I will write some reactions, we will directly learn about them. I will also write what mechanism do they follow. So ROH2 RX, this is our target. First reaction is ROH on reaction with PCl5 or PX5. Let us say X is the halogen. So this reaction follows SN2 path. The product will be RCl, RX plus HX plus POX3. Similarly, next reaction could be ROH on reaction with PX3. Here we use 3 equivalents, guys. So this is important part, that how many equivalents are we using? 3. So this 3 equivalent will form what? 3 equivalents of RX plus H3 PO3. This also follows which mechanism? SN2. Third, ROH on reaction with thionyl chloride or thionyl bromide. This reaction follows SNI mechanism, intramolecular nucleophilic substitution, and it gives you RX plus SO2 plus HCl. Then we have fourth reaction, ROH plus SOCl2 in the presence of pyridine. This reaction now follows SN2 path, and it forms RX plus pyridinium chloride. plus halogen gas, plus this SO2 gas. So that is what we follow. There is one more way that we synthesize it from, that ROH on reaction with HX in presence of anhydrous ZnCl2, and this process follows SN1 mechanism, and the product will be Rx plus H2O. This is SN1. So guys, wherever you can find SN1, SN2, SNI, do remember this part. This is highly important part to all of us. Dimple is asking me some doubt. Please mention your doubt. Now check it out, everyone, check it out. This reaction SNI is said to be the most efficient way to prepare Rx. This is said to be most efficient way because the products, all the byproducts are gaseous and they all eliminate out. Why is it so? Because all byproducts are gases and they leave around, they leave the system and they leave behind the only final product. This is all about ROH. Majorly the mechanism part of SN1, SN2, SNI, using the same examples. I have already explained this part in my very important session we had called as reaction mechanism. Now this is something which is completed. So this reaction by addition of HX is called as Lucas test. So guys, the Lucas reagent, is concentrated HCl plus anhydrous ZnCl2. This combination is actually producing Cl positive for you. Not Cl positive, yaar. H positive attacks in first step. Carbocation is formed as an intermediate. Carbocation is get back attacked with ZnCl2. So sorry, Cl minus attacks over there. So that's how this reaction works. So there are two purposes of ZnCl2. Anhydrous ZnCl2 increases the rate of reaction. Why? It works as a catalyst, guys. First of all, it is anhydrous, so it absorbs the water formed in the product side. The another one is it activates your alcoholic part by directly attacking upon ZnCl2 and easily removes out this OH group from hydrocarbon to create a carbocation. So anyways, 1 degree immediately 1 degree does not give any visible reaction on room temperature. 2 degree gives 5 to 10 minutes and 3 degree gives immediately. This is what Lucas test is all about. ROH plus ZnCl2 and this HCl gives you RCl plus H2O. This RCl you formed, if it is R is your 3 degree, immediately reaction happen. 2 degree 5 to 10 minutes, or for 1 degree it doesn't happen. That is what the reaction part is. Now well guys, I'm moving forward. This is the preparation of HX you can do. HCl is already been provided to you. HBr you want to prepare, NaBr plus H2SO4 gives you HUBr. And in the similar way, if you want to prepare the HI can be prepared by using H3PO3 plus Na, and it will give you HI plus Na3PO4. HI on reaction with anhydrous and Cl2 gives you Ri and H2. Not so big thing which we are doing. It has been already covered by us, not just in our previous chapter of reaction mechanism, but also here also we have covered it. How many moles of alkyl chloride can be formed if we are using 1 mole of PCl3 requires 3 moles of alcohol. So 3 moles of alcohol with PCl3, always remember this reaction follows an SN2 path, and it forms what? Rx or RCl, 3RCl plus H3PO3 or POH whole thrice, we can also write it H3PO3. So how many equivalents are we using? 3 moles. And how many of Rx we are making? 3 moles we are making using 1 mole. Correct answer should be B. Give me the pressure product. See, we have been tired by doing the same questions again and again, everyone. This will go attack on the hydrogen. OH2 group will be eliminated out. Right after removal of water, the first product that will be formed is, in the first step after removing H2, you get a product like this, which is a carbocation. So after removing this will be your carbocation. Now check it out whether this is stable, or you can make it more stable. Now we can see that this is already stable because the resonance stability is here. So guys, simply what we'll do, we'll get this Br minus attacked, and the final product will somehow look like this. Another question, NaH3PO4. What does NaH3PO4 produces? It produces first of all HI plus Na3PO4. Okay, H3PO4 was there. HI it will produce. So HI is actually your attacking reagent. H plus will come up. So the first thing that will form after attacking of H positive and then elimination of water, the first thing that will be prepared is CH3, CH2, CH3, H, CH2 positive. But this is 1 degree carbocation which is not stable. 1 degree want to get stabilized. This hydrogen 1, 2, hydrogen shift 1, 2, H minus hydride shift will take place. Hydrogen leaves its position, preparing another carbocation which looks like this, which is a 3 degree carbocation which is more stable. In the final step, I minus will come and attack, and this will be your final product, CH3, CH2, C, I, CH3, CH3. Let me know if you face any doubt. This is the final or major product. Tertiary product will be there, 3 degree alkyl iodide. A question is here that ethylene glycol reacts with PCl5 to give what? Ethylene glycol. What is ethylene glycol? This is your ethylene glycol. CH2. Ethylene term is there. That means OH will be there. We are reacting with PCl5. So let us suppose we are using 2 equivalents here. So guys, this will produce CH2, Cl, Cl plus 2 POCl3 plus 2 HCl. See how easy is this? And the mechanism, no doubt, SN2. One more question we have. We know that under such circumstances, pyridine behaves like a, I already explained this part in this chapter also, ongoing lecture also, in previous reaction mechanism part also, that it follows SN2 path in the presence of this pyridine. Because pyridine, what does? Pyridine accepts H positive and immediately creates Cl minus available for attack, for an SN2 attack. But in the case of SNI, since there was no external reagent like this, in the very first step, Cl minus departs and attacks on the same side. Wherever it is departing, it attacks from the same side. So SNI reaction happens over here, SNI, and this favors SN2 path. So the product will be inverted product. So you have to put Cl over here, D over here, deuterium. This is CH3, this is D. So what you are observing is Walden inversion. Inverted product is there. Okay, if the same priority is there of the leaving group and attacking reagent, then it will R configuration will convert it to S, S configuration will convert it to R. Now if we talk about this will be having S and I. I means same side attack. So same side attack takes place in such a way. This is called as retention of configuration. This is called as retention of configuration. Why primary alcohols are least reactive towards the Lucas reagent? Because this follows SN1 reaction mechanism, and the rate of SN1 reaction is 3 degree, 2 degree, 1 degree. This is the rate of SN1 reaction, which is directly proportional to the stability of carbocation. So 3 degree carbocation will be more stable, 1 degree will be the least stable. That's why 1 degree have the least reaction towards Lucas reagent as an SN1 reaction. As I was telling you everyone that we have a big reveal on 10th of coming month, 10th of December. We have a big event to attend with. We are highly excited. We all panel are pretty much excited. We'll be attending that event and we'll be enjoying there a lot. Apart from our enjoyment, your major enjoyment comes because we'll be revealing so many good offers for you people who can join us in our coming days and for your upcoming journey of JEE Mains Advanced, or it could be like 2026 journey also. So we have just not 5 days right now, only 3 or 4 days have been left here from here, or I guess day after tomorrow will be the day. What is the date today? Oh my god, today is 8th. So go on JEE Nexus right now. Go on JEE Nexus channel and do notify it. Just notify it. Notification will be enough. And December 10th will be the 7 PM onwards. You will be watching us performing there. And let's see what happens. Even we are equally excited and we have no clue further what is gonna to come. We have best method of preparation. Best method I told you. It is SNI reaction. And why is it? Because RCl, SO2 and HCl, all byproducts are gaseous, removed easily, leaving behind main product. Which of the following reagent cannot be used for the preparation of alkyl halide from alcohol? Alcohols, this also does, this also does, this. AgF is correct. Silver fluoride does not react there with alcohols. No reaction is there, and I don't know what will be there, but at least alkyl halide will not be formed. Then we have from carbonyl compound. So guys, see, this reaction can be taken up as like this. Carbonyl compound CHO. CHO can also be written down as like this. So we have two OH groups with us. So these two OH groups in the 2 PCl5, two equivalents we are taken, will give you what? Cl and Cl. So 2 PoCl3 will be eliminated out. Like that. And I think we don't need to write down the HX as well. And we are not supposed to take the two equivalents. Even one equivalent can be enough in this condition. I guess we should take only one PCl5 plus POCl3 will be the final byproduct. This is enough. If you want to know what mechanism does it follow, I can explain. So considering that the phosphorus which belongs to third period, it has vacant d orbital, so it can form a compound like this. I think we can take two equivalents, guys. I think we're right that time. We have to take two equivalent. So it forms some compound like this. One, two, three, four, and fifth will be eliminated out. Let's say this is fifth. So this attacks on this such a way that it will be eliminated out. One of them will be eliminated out as a Cl. So this Cl minus actually it's a single step considered mechanism. So what exactly happens here? It attacks on and this Cl immediately departs, and after departing it comes back and attack on this, leaving behind this group. Now check it out, what is it? Right after removing HCl, we have CH3 Cl, CH3 C, Cl and Cl, and here also CH3 is there, plus POCl3 will be the byproduct. So this is some reaction is there, everyone, and that's why I told you that don't get confused while going with the reaction. Simply take this example that the attack over here is SN2, one step concerted mechanism. Next we have action of SF4. So the SF4 also does the same kind of reaction where treatment of SF4 with carbonyl compound converts into organofluoride compound. So if you have to prepare organofluoride compound, then it works SF4. So carboxylic acid, trifluoromethyl compound, aldehyde and ketones, difluoro compounds. We have reaction with silver salts of the acids. This reaction is called as Huns-Diecker reaction, which is one of the very important reaction, a naming reaction, in which what we are doing, we have a silver salt, we are reacting with Br2 in presence of CCl4, RBr, CO2, AgBr is product. So RBr can be formed like this, but we must understand that it's a free radical reaction. Mechanism is also given, thankfully. So what is happening here? The reaction proceeds by free radical. So let us suppose this is a free radical. So AgBr will be eliminated out, and this forms RC double bond O. O radical is here. This O radical rearrange itself like this. And it gives you R radical, and CO2 gas eliminates out. This R radicals combines with Br radical, forms RBr. But what happens if R is 3 degree? But what happens if R is 3 degree? If Rx sorry, R C double bond O Ag we are taking. Let's suppose this R is 3 degree. Then esters are the major product. So we can say that this reaction is not suitable. This reaction is not suitable for the preparation of 3 degree RX. Why am I saying it? Because, and the reaction becomes the another name of this reaction, I'll tell you. So this is what is happening. RC double bond O radical, and this is a 3 degree. Let's say this is 3 degree. This comes and directly attacks on already formed radical, which is RCO radical, and it directly forms CH3 CH3, and this reaction is called as Birbom-Simonini reaction. Earlier we were calling it as Huns-Diker reaction. Huns-Diker reaction now has become Birbom-Simonini. When, if we are using a tertiary alkyl in the carboxylic salts of silver, what will be the product of the reaction PCl5 with acetone? Oh my god, we already have covered this part. Well, there will be two halogen attached with the C double bond O part, acetone. So you can check it out by your own. Which of the following compound will form 1,1 dihydrochloropropane with PCl5? Oh my god, yeah, similar questions have been asked. Propanol. Treatment of SF4, it will be, it's a fluorinating agent. Homework, you do it. Huns-Diker reaction, number of carbon atom decrease. Yes, one carbon atom decreases in the form of CO2. Silver acetate is formed with bromine. The main product is silver acetate with bromine. Silver acetate is CH3, C double bond O, OAG. This on reaction with bromine CCl4 will give you CH3Br as the product, plus AgBr will be suspended and CO2 will be eliminated. Correct answer should be B. So one lesser carbon atom we are receiving in this reaction. One lesser carbon atom. Next is halogen exchange reaction. Halogen exchange reactions. So what happens in this reaction? Halogen exchange, yeah. These reactions are actually, there are two important reactions, Finkelstein and Schwarz reaction. And you believe me, these all follow SN2 mechanism. So what we are taking is acetone, and in acetone we are having a strong nucleophile. We all know that iodine itself works as a strong nucleophile as well as strong as a stable leaving group also. Both work can be done by iodine. So iodide ion comes and replaces Cl or Br from 1 degree or 2 degree substrate. 1 degree, 2 degree. Why are we taking not 3 degree? Because it's SN2. So SN2 reactions is not strictly, does not obey for 3 degree. So NaCl and NaBr will be separated out as precipitate, and the remaining product will be Ri. This reaction takes place in the order of NaF, NaCl, NaBr, NaI, because due to more repulsion of solvent and nucleus rate of decreases like this. Okay, this is the actually SN2 reaction will take place. Then we have another reaction, Schwartz reaction, in which RCl, RB, or RI are supposed to be attacked by silver fluoride and forms the RF, and AgCl, AgI will be deposited there. Again, this reaction is SN2 part, SN2 reaction. Another reagent such as SbF3, Hg2F2, CuF2 can also be used in the place of AgF. Believe me, these reactions are very important. They are called as what we call them? Halogen exchange we call them, because we are exchanging the halogens. Some good reactions. Okay, the reaction alkyl iodide. Okay, Ri to this is Finkelstein. Remember guys, RBR, we are getting it reacted with NaI acetone. This is Ri, and NaBr will be precipitated out. This reaction is called as Finkelstein. Schwartz's reaction with AgF, SbF3, Hg2F2, and the product will be fluoride. Try this question. This was asked back in JEE Main 2022. Let's see who can solve this question. JEE Main 2022. Exactly 2 years back, this question was asked. What does this question say? The major product in the reaction is, first we are getting it attacked with H+. Now we have two things. One of them is OH, another one is double bond. Which should attack first? Yeah, I think O must go and attack it first, because why? Because oxygen is having lone pair on, and this is under the influence of one nucleus only. Here it is under the influence of pi electrons, are under the influence 2 carbon atom only. First attack should be taken place by OH. Then, and we'll see if we are not getting the correct product, then we'll decide it accordingly. But as of now, we should prepare a final product like this. And there is a positive charged. Then we are heating it. First we are heating it to eliminate it out. OH2 will be formed. This will be eliminated out. Great. Then what will happen in the next step? This is an electrophile which we have got now. This will attack onto this. So the product formed will be one. This is where we are 1, 2, 3, 4, 5, 6, and this is like negative, this is positive, this is positive, this is negative. So we can also like it like just simply make it a negative and a positive and just attack like this. So this will give you pentavalent ring. The one carbon over here is this minus which is connected over there. This is having this group, and the one which is attached with over here is this. So rest is the same, like this. So we have got some product like this. So wherever we are attacking it with, this is acquiring a positive charge now. In the last step, because of the presence of Br, minus will come, and this will give you your final product. See, please try this question by your own also, apart from me. Yeah, hello. So that was a good question, by the way. the one we are right now studying, and some mixed question from hydrocarbons, alkene was attacking, but always consider this first attack will be taking from OH. Then we have physical properties of RX. So once we cover the physical properties, we'll take a small break. I'll go for a breakfast, actually getting hungry. We'll take a break and then I'll come back and we'll start the same from there. So physical properties are pretty easy, that we all know. Their color, they are actually turbid in color. They are not even colorless. They are more or less turbid, cloudy in appearance, like dirty looking, off color they show, and they develop color when exposed to light, but generally they are like colorless only. Their physical state, these like CH3Cl, C2Br and CH3EtCl, these are some gases at room temperature. Rest are the liquids or solids. Higher one are liquids and solid. Density keeps on increasing if the halogen atom with higher molecular mass is there, and density keeps on increasing if we also increase their atomic mass in terms of halogen, and also if we increase the number of carbon atoms. Solubility, they do not get dissolved easily because they cannot form hydrogen bonding with water, but in acetone, DMS, so in these solvent it can dissolve easily. In organic solvent it can dissolve easily. Then if we talk about the boiling points, guys, boiling points increases if we increase the number of carbon atom. Boiling point decreases if you increase the number of branches in it. With the increase of branches, their boiling point decreases, because with increase in branches their surface area decreases. Surface area decreases, van der Waals force of attraction decreases, van der Waals force of attraction decreases, their boiling point decreases. So which is very much easily given over here. Now you can check it out, that 375 Kelvin is the temperature boiling point for method prop N-butane butyl. This is your secondary butyl, and then this is your tertiary butyl. So higher is the number of chains, lesser is the boiling point. And also boiling point is directly proportional to the mu, dipole moment. So wherever molecules have been given, we all know which one will be having the dipole moment of will follow the order of first, second and then third. So third will be having the least boiling point but highest melting point also, because melting point comes up with the melting point is decided by the packing and symmetry in the molecule. So due to symmetry it is having highest melting point, but due to less dipole moment it is having least boiling point. Which of the following is most likely to be colored? Alkyl chloride, iodide. Why? Just apply Pajan's rule. Pajan's rule says that color imparting tendency of the molecules is directly proportional to covalent character. Covalent character of molecule is directly proportional to the polarizing ability of anion, and the anion with bigger size will have higher polarizability. The boiling point of chloroalkane decreases with increase in the size of. Wrong, false. Why boiling point of straight shell are higher? Because they have more sizes, more size or more surface area will give them more van der Waals force of attraction. Why melting point with para is higher? Because of the symmetry, because of the packing. The correct decreasing order of densities of this compound. Density, what do you think? So guys, higher is the molecular mass, higher will be density. D will be the highest, then C, then B, then A. So D, C, B, A is the correct answer. Higher is the molecular mass, higher is the density also. What is the correct formula of the boiling point of these compound? Chlorofluorobromoiodo. Boiling point will increase as you go with the higher in size. So this is the correct answer. And then we have chemical properties of the RX. and for this we'll quickly continue it. I need a break, short break, guys. Hopefully you all are enjoying this session, and we will connect very soon. Please don't go anywhere. And I found that we were continuously studying it, and we had a good response from the student side also. I am leaving for a quick breakfast, so we'll continue. But before that, it's a short break. Those who haven't liked us, so do like this session. We have plenty of things left from here. Chemical properties, then we'll be having Hi folks, so the short break is over now. Hopefully this was very healthy break. So now we have come to the next part of this session, which is chemical properties of haloalkanes and haloarenes also, but haloarenes will require some more time. We need to prepare haloarenes first and then we'll come to the chemical properties. So let us start the chemical reactions. The very first chemical reaction, two reactions are very much characteristic reaction. One of them is nucleophilic addition, substitution, SN reactions, and the another one is elimination reactions. You already have gone through these type of reactions, their examples and their mechanisms in the reaction mechanism chapter. So now I'll directly come, we'll explain one by one, and there we have some basic idea like leaving groups. What are leaving groups? What is base? What is nucleophile? A nucleophile also contains a negative charge over it, and the best part of nucleophile is it attacks upon the carbon of the substrate. We also call that part as a nucleophilic center. So nucleophilic center is something where nucleophile is going to attack. So it attacks over here on the carbon, halogen departs in the form of X minus. X minus being a good leaving group, it departs easily. Base, what does a base do? Base comes and attacks upon the alpha hydrogen, which is also called as the acidic hydrogen. Why are we calling it acidic hydrogen? Because after removal of hydrogen, the transfer of the electron density takes place in such a way that it departs the halogen, and that is what it makes that alpha hydrogen of a haloalkane as an acidic hydrogen. The similar thing happens whenever any electron withdrawing group is attached there at the alpha position. So let me just show you that this carbon is called as alpha, and the very next carbon to it will be calling as beta. So this is your alpha carbon, this is your beta carbon. Hydrogen to beta becomes acidic, it releases down its electron density over here and departs halogen in the form of halide, and an alkene is formed as a product of elimination. So this is your elimination reaction, this is your what we call it, sir. The mole concept session did not cover these part. Anyways guys, you can study, you can read it by your own also. You people study these all classic, what we call it, yeah, Dalton's atomic theory and laws of chemical combination in 9th standard also. So don't worry, we have not skipped too much of the thing, but I'll cover them later on, not worry. Now coming to our original topic, we are right now in the 12th standard. We have this organic chemistry ongoing. So the decreasing order of leaving group ability is this, which is what we have to learn, and it's pretty easy to learn about because nitrogen is the most stable group or the molecule which is having a nitrogen, triple bond nitrogen in it, and that is what it makes it more stable. It can easily be removed out and it's a good leaving group. So wherever it departs from, it can cause a positive charge on the substrate. Then moving forward, nucleophile can attack and can form whatever the compound is required. We have this compound is called as triflate. This is OT, is tosylate, brosylate, mesylate, iodide. This is the order of leaving group. So I minus is relatively more stable than fluoride because I minus has a distributed charge density, more distributed charge density because of its bigger size, whereas fluoride has a smaller charge density, like high charge density because of its smaller size. This is SN1 versus SN2 reactions. Why am I not going individually with these reactions? Because this part is already covered by us. We will take a quick idea and we'll move forward. SN1 reactions are unimolecular reactions in which more than one step takes place to cover the proper reaction. Substrate first leaves the halogen atom and then forming a carbocation. Then the carbocation gets attacked by a nucleophile. If the carbocation can go under rearrangement, then it will go under that. If the possibility is there, it will go under rearrangement. Final product or the final stable carbocation will be attacked by nucleophile, giving you the substituted product. Now what you can do is, if there is a rearrangement probability, then you need to rearrange it. In that way it can take even more than 2 steps, but if there is no rearrangement possibility, then minimum of 2 steps will be there in SN1 reaction. While coming to the SN2 reaction, SN2 reaction takes place in just one step and we call it one-step concerted mechanism in that a strong nucleophile comes in the presence of uh, polar aprotic solvent. This reaction takes place because nucleophile with a negative charge is not hydrated or solvated in the case of polar aprotic solvent, but in the case of polar protic or water or alcohol kind of solvents, they can easily hydrate or solvate the anion nucleophile, and that reduces its nucleophilicity. So that is what I'm trying to say, and this act takes place in one step. There is no intermediates formed, only transition state will form like this, and the reaction takes place like this. So one thing that you should remind is, whenever in SN1 reaction we go for this energetics graph where potential energy versus reaction coordinate is shown here in the terms of energy, first transition state will be having higher energy, then second and third and so on will be having relatively stable form, and they will be having lesser energy. So the first peak will be that the highest, followed by this. So this graph, if let's say there are more than one steps are involved in order to stabilize the carbocation under rearrangement, this is how it will look like. But the peaks of the transition states, you can find it will keep on decreasing. Next, what do you think? Which one should go SN1 easily? So guys, SN1 follows the order of stability of carbocation, which is 3 degree, 2 degree, 1 degree, or what we can say reso-stable carbocation will give you the major product or the faster rate of reaction. So allyl is what? CH3. Allyl is what? CH2, double bond CH, single bond CH2, single bond Cl. So this after removal will acquire a positive charge, which is a reso-stable. So this is the correct answer, A. Allylic carbocations are resonance stabilized carbocations, and that is why SN1 reaction will favor what? Allyl bromide in the faster way than ethyl bromide, because there is no as such external stability is not provided to the carbocation. That's why. We have a question that was asked back in JEE in 2014. 2014 में पूछा गया ये सवाल. Everybody please have a focus over here and let's look over this question. What is being asked? We right now have been given that SN2 reaction for the correct order of reactivity will be what? So guys, this is pretty easy, that rate of reaction occurs in such a way: 1 degree, 2 degree, 3 degree, even 0 degree. This is the order of SN2, because SN2 reaction, like the mechanism I have told you in the previous sessions, the mechanism follows a formation of pentavalent transition state, which is stabilized by less bulkier group and destabilizes itself by the presence of bulkier group. That's why 3 degree do not give SN2. So correct answer should be C. 0 degree, 1 degree, 2 degree, 3 degree. B is the correct answer. B is the correct answer. Next is the major product of the following reaction is. So first let me identify where is the reaction. This is the reaction. First is aqueous NaOH. Then we have CH3I. So guys, I personally think that this reaction is pretty tough to understand, as aqueous NaOH will make it O minus. Okay, now I got this reaction. Look at it, everyone. So how does this reaction proceed? We have a benzene looking like substance with a CH3 group over here, and it forms O minus Na plus, where it becomes what? A nucleophile. This nucleophile attacks over methyl iodide like this. Iodine departs and a compound like this will be formed here. One is CH3 here, sorry, OCH3 will be here. It is already CH3 here, and the byproduct will become NaI, sodium iodide. Now check it out. Where can you find this option? I think A is the correct option. Yeah, A is correct. Next, about SN1 and SN2 reactions. The SN1 reaction is unimolecular while SN2 is bimolecular, true. Polar protic solvent required SN1. True, because in polar protic solvent, the first step is called as the removal of leaving group, which is the RDS, formation of carbocation takes place in that. So polar protic solvent actually stabilizes the carbocation and helps to maintain the polarity of carbon halogen bond. So yes, this is correct. While aprotic solvent in SN2, that is also correct, because SN2 reaction wants nucleophile to be very strong to attack in one step concentrated mechanism, and SN2 favors with aprotic solvent. Both of them depend upon the substrate. Yes, SN1 depends only upon the concentration of substrate, while SN2 depends on the concentration of substrate as well as nucleophile. So the correct answer should be D. All of them are correct. Next, what is this reaction? This is 1 degree substrate. So undoubtedly this will follow SN2 first. So this is O minus and Na plus. O minus will go here, attack, simply removes out it. OC2H5 will be the product and it will follow SN2 path. Very easy. Right. So among the primary, secondary, tertiary, which halide should undergo? We all know about it. Among SN acid, which involves racemization. SN1 involves racemization. That too is partial racemization, because D and L form can be formed with different inverted configurations. But the major part is whenever a nucleophile attacks from the same side in which leaving group was exiting, the yield will be a bit lesser. Although we always say that the first step is the formation of carbocation, but in fact everything happens that quickly that whenever opposite side attack will be taking place, it will be going with an ease, and that in the same direction of leaving group will be causing a bit of the hindrance, and that is what it causes partial racemization in SN1. SN1 reaction can occur with the products of like 40-60 ratio, or like 45-55 kind of ratio, or 30-70 also, but again it's a partial racemization, and both of them will be formed as a yield in major quantity, significant quantity. SN2 always happens with the 100% inversion. What is the difference between transition state and intermediate? So guys, intermediate is actually a short-lived species that actually exists, but a transition state is just a concept and a hypothetical concept. Intermediate can be isolated also. A carbocation, a anion, a carbene, a carbon free radical can be isolated also. But you can't isolate a transition state, and transition state is actually also called as activated complex. How to decide whether SN1 with various factors, man. There we have a question. Now let's see who can solve this question. Try everyone. This question is for us. We have a question here. We have a question that the major product of the following reaction is what? We have been given up with CH3OH. The medium is polar. Undoubtedly, the first product will be removal of this, formation of a carbocation, which will be at 2 degree. So now what does this do? It undergoes 1,2 H minus shift. Maybe it can become a 3 degree. So CH3, CCH3. This is with positive charge, CH2, CH3. This is what it will form after rearrangement, and then finally you will be getting attacked by methanol. Methanol will attack, and at last hydrogen will be departed. So the compound formed will be OCH3 will be attacked, CH2, CH3. If heat would have been given, then we will take the elimination part. But since the temperature is normal and not given anything as heat, we have to form the substituted product only. My correct answer is A. You also can pick your own answer, guys. It's not about that I'm a teacher and I will always give you the correct answer. I am a human being. I also can commit mistakes. But who can resolve and who can basically identify the mistakes? That is you. So I always suggest you that please submit your answers in comment section, and even if you are facing any doubt or even if you are not able to answer it, just have a try on the question. That will increase your confidence, and that is the what key of learning. We have similar question asked in JEE Main 2017. In JEE Main 2017, this question was asked. What is this question about? We have this question asking us that on increasing order of the reactivity for SN1, guys, SN1 you all know directly proportional to the stability of carbocation. So third will be the highest, then we have first, and then we have second. This is the order of stability of carbocation and also the rate of SN1 addition. D is the correct answer as I see. D is the correct answer. Next question, JEE Main 2024. This year only this question was asked, only this year. So now see, let us see what is this question about. Among the following halide, which one will will not show SN1. So guys, what will not show SN? This is something where SN1 SN2 doesn't work because this has a partial double bond character, due to which a double bond is created here and it is not easy to depart it. This goes very easily. We call it vinylic. It is allylic. Sorry, oppositely said. This is vinylic. That doesn't work. And this is allylic. This goes very easily because the formation of carbocation will be very stable carbocation because of the resonance. This is called as benzylic. This goes very easily. This is a 2 degree. 2 degree carbocation will be there, but still I think it goes. Now let us see where can we find the correct answer. I think B is the only one that doesn't give you this reaction. And now let's see whether we are right or wrong. We are absolutely correct. We have got positive 4 marks, and you now can realize how easy questions have been asked these days in JEE Main, even in JEE Advanced. The only part that we have to make clear of is proper attendance of the lecture. I always find this, that whenever I take the lecture, very few crowd watches it right after the lecture. You may or may not watch, but the major benefit of the class you only can get whenever I'm live over here. You may post your doubt out. I take all the doubts and comments very seriously. I reply them. So guys, just make a good habit and please be very conscious. That's why I say that subscribe to this channel and notify the lectures, upcoming lectures, so that whenever the lecture happens, sit properly with me. It might take hardly 4 hours, 3 hours, 5 hours, but believe me, that concept and that chapter will be very much enough, and you can fight any kind of exam you are appearing on that chapter based upon. So guys, be confident and always follow us properly. JEE Main 2024, one more question was asked. Correct statement regarding the nucleophilic substitution reaction in chiral halide. Chiral halide means something which is having optically active compound, and now we are going SN retention occurs in SN1. No, SN1 doesn't undergo retention, it goes racemization, and this is correct. Inversion is correct. Retention occurs in SN1. No. Racemization occur, correct. Inversion occur, no. Retention doesn't occur. Racemization occur in SN1, retention, inversion occur in this. D is correct. Now see how easy these questions are. This was asked in 2024. D is correct. Then I'll give you this idea of SN-NGP. We also call this reaction as neighboring group participation, and this SN is nucleophilic substitution. So what happens, we have an external agent that helps us to go through this reaction fastly. So let us say this is something which is undergoing SN2 reaction, this is undergoing SN-NGP. So how this reaction takes place, everyone, just take this example. This is like we have prepared our subsidiary or the parts of a car from different companies, and we have just assembled it. that assembling will take us lesser time. And if some company is preparing all the bypass by itself only, then it will take more time to create that car. So that is what it happens. So in this kind of reaction, this first of all very much attack over here and leaves the chlorine in first step only. This is your SNNGP, and this is also a 1 degree, the order is 1 only. So that is how it look like, SPH positive, and there we have hydrogen, and there we have a, that's how it look like. Now what you can do is, this is also having 1 hydrogen, HCl was there, no? So in the next step, some attacking nucleophile may come and attack on the either of the side, and then it departs like this. So this is attacked over here, nucleophile, and this is where it goes with SPH. So I think this also occurs with the retention of configuration. Can you check it? So this was attacking from the back side, and then again it is attacking from the back side. It is going for the retention. Retention of configuration takes place. This is retention of configuration, and that is why it makes neighboring group participation reactions faster than SN1 and SN2. Then we have silent features. That is what we have covered in our previous lecture also. So we will take this idea and then we will move to the forward part. That NGP leaving group, and they all must anti to each other, the neighboring group which is gonna to attack. Neighboring group plus inversion, first inversion takes place. First NGP is inverting and then nucleophile attacks on the inverted. 2 inversion means retention of configuration takes place. It is intramolecular SN2 reaction, and the rate of reaction is proportional to the concentration of reactant only, as I told you. The first part is the slow step and this is the RDS. So directly proportional to the only reactant part only, substrate, and NGP is the first order reaction. This, which of the reaction occurs at the faster rate? First of all, this will attack here, leaving behind this, and then OH minus comes. I think B is the correct answer, because this will follow what? SNNGP, and this is following simply SN2. So which one should go faster rate? SNNGP. NGP is first order, correct. NGP faster than, yes, NGP nucleophile, and they must be anti, correct. D. Which of the following substitute will not favor nucleophilic substitution by SN or SN2? You cannot form a carbocation here because sp2 hybridized carbon has a bond angle of 120 degree, but it is always like into 3-dimensional structure, and I personally think that these are non-planarity will not lead this to remove. Number 1, no SN1, no SN2. This also have no SN1, SN2 because of the partial balloon character. Here it's a very bulky group, as you can see. It's a very bulky group which doesn't allow this. Also the breakage of this will give you 1 degree carbocation only. So this is not going SN1. SN1, why? Because 1 degree carbocation is there. And SN2, why doesn't it give SN2? Because of the bulky group. Bulky group causes steric hindrance. All of the correct answer. All of them are correct. We have a question asked in JEE Main 2022. Check it out, everyone. Check it out. We have a question here. the stable product of the reaction is, so it is happening in the reaction, so SN2 will occur at the first step and then again SN2 will occur. So in the very first step you will form a compound. This compound is what? OH will be replaced by Cl and SN2. In the presence of pyridine it is giving SN2. Then now this reaction with NaCN and DMF also follows SN2. So SN2, this will give you, this is not changed, this will again change to this and it will become a CN. Now check it out. The correct answer should be, I think, A. A is the correct. No A, yaar, man, what's wrong with them? But A and B are the same compounds only. As you can see, A and B are the same only. They are mirror images of each other. Now, I didn't get this. First you do SN2. The another SN2 will give you a same side configuration. Something might be wrong here. This is also correct. These are to say these two are the identical compound only. These two are identical. We are just rotating it. These are some set of important nucleophilic substitution reaction that you should understand. So guys, the reactions are pretty easy and what product will be formed is mentioned here. Although we have known about the, okay, we have some problem here. Somebody is in pain. I think he's mentioning his pain. No problem. We will come back to our chemical reactions. We already have covered this part of reaction mechanism. We know that how SN1, SN2, SNI and SNNGP work. Now after knowing all the mechanism, we must know that what reagent can cause what product. That is what we must know. This is Rx, which is your substrate. This substrate has been attacked by some reagent like AGF. It is undergoing SN2 reaction, you all know. So SN2 reaction takes place in intramolecular, sorry, we call it inter-halogen exchange reaction. So this RF will be the product called as Schwarz reaction. Similarly, NaOH in aqueous solution will give you ROH. Same with Na2S give you RSR, thioether. Then ROR, RCOR. It's very simple. Like whatever the nucleophile is there that is attacked over there or leaving behind the halide ion as leaving group. Just learn it. There is one thing I want to mention here, if it is not. Guys, whenever we are given with some Rx, and let's say I'm attacking this with KCN. So K plus or Cn minus have a permanent ready-made cyanide ion over there. That means this cyanide ion with negative charge on carbon will attack and will form a RCN compound. So we are getting what? Nitriles we are getting, alkane nitriles, or we can call it alkyl cyanide we are getting. If I react this with AgCN, so guys, AgCN has a covalent character. It's a covalent bond between Ag, transition metal and carbon, which results in the formation of this nitrogen goes on attack. So that is why the compound formed will be RNC. What is RNC? Carbylamine, alkyl cyanide, isocyanide, or alkane isonitrile. Or carbylamine, alkane carbylamine or alkyl carbylamine. So that is what very important part is. And let me just elaborate this part for one more thing. If we get this part reacted with NaNO2 or KNO2, so guys, in this nitrogen has a negative charge, so RONO will be the product, nitrite will be the product, ONO. And if you react the same reaction with AgNO2, so nitrogen, oxygen is already attached here with silver. So try to understand, this is how the structure look like. And that with this attacks. Here Na plus, oxygen attacks here. So ONO will be product, here RNO2 will be formed. So these four are very critical and very important examples that we must know, that if we are given with RX, which is RX is our alkyl halide, attack of KCN gives this, AgCN gives this, NaNO2 gives this, AgNO2 gives this. Learn it, and the logic or the reason is already mentioned here. The logic is already mentioned here. Here is a question. Alkyl halide is converted into alkyl isocyanide by which of the reaction? Alkyl isocyanide will be produced by AgCNC. AgCN. Oh wow, yaar, JEE 2024 asked the same question. Very easy, yaar. Right now, I told you. JEE 2024 has a question. Given below are two statements. One of them is labeled as assertion A and the other one is labeled as R. Assertion A says that haloalkane react with KCN to form alkyl cyanide. Correct. As with the product of AgCN will be SN. Correct. This is true. KCN and AgCN both are highly ionic compound. No, AgCN is predominantly covalent compound. So this is false. So R is wrong. A is correct. A is correct. See how easy these questions are. Then we have elimination reactions. What happens in elimination reactions? We have a leaving group that will leave, and alkenes are formed in the terms of beta elimination we carry out. So alpha elimination, beta and 1,3 or 1n elimination. But we are only concerned about the type of beta elimination only. So beta will include what? E1, E2, E1 CB and EI elimination. But Rx will give only 3 given by alkyl halide gives only these three Rx. Even CB is given by esters, COP elimination, xanthates, and amino oxides, ammonium oxides. So that is what it gives with. This reaction alpha elimination is also called as 1,1 elimination, in which carbene. So we covered this part, will not go under this, not even important right now. Beta is highly important to us, even E2, even so we will take an idea and we'll move forward fast quickly. So 1,3, 1n elimination is something where a cyclic ring is formed either in the terms of cyclic ethers, just shown it over there, in the presence of base. Which of the following compound cannot give beta elimination? Which will not be having a beta carbon? So methyl iodide doesn't have. Only alpha is there, no beta. No beta carbon. So how can it give you? The B is the correct answer. Which of the following is elimination reaction? Which of the following is an elimination? Elimination always causes alkene as the product, and some bi part is actually removed. So HCl will be removed. HCl plus KOH will form what? H2O plus KCl. Ease of dehydrogenation. It is the same, only the leaving group ability will decide it. Iodides are more stable than bromide, then chloride, then fluoride. The correct answer should be iodide, bromide, chloride. The product of this reaction, we have alcoholic KOH here, everyone. We all know about SN E2 eliminations. How does E2 elimination takes place? They should be anti-periplanar, where it is going to attack with. So what you find is this is having hydrogen over here, and not this one here. It's not even required to create it. This is hydrogen. This is also hydrogen. This is also hydrogen, beta hydrogen. But either of the way is fine. Anything can be taken. And alcoholic KOH will cause what? E2 elimination. So the product will be Br will be eliminated out. One product is this, not yaar, this. This is your product. This all will be planar. Now tell me the correct name of this compound. 1,3-dimethyl butene. I don't know what is wrong with these here. Options are not good here. This is not butene, this is a cyclic compound. Anyways, let us come to the comparison of E1 and E2. So E1 elimination is something in which weak base and generally solvent is taken. Polar protic solvent we take 3 degree, 2 degree, 1 degree as per the stability of carbocation. Better one is required. Leaving group always better is needed. I minus followed by Br minus followed by Cl minus followed by F minus. It's a first order, depends only upon Rx. Its ZF alkene is a major product and no special geometry is required. No special geometry is in, because the formation of carbocation decides everything. We do not need to take this concern that whether the leaving group is in anti-periplanar to the hydrogen all. So now E2 elimination is something where we require a strong base, exactly like SN2. Wide varieties of solvent we can take, but yes, mostly polar aprotic is preferred. 3 degree, 2 degree, 1 degree is the order, because the stability of alkene formed is deciding the rate of reaction. Then better one is required always, the leaving group. It is dependent upon the concentration of base as well as Rx. That's why it is called as second order, and we call it E2 elimination, not E1. Then we have ZF alkene will be formed as the major product. Transition state can be anti-periplanar, coplanar. That means the leaving group and the hydrogen, beta hydrogen, should be in same plane but anti to each other. That is called as anti-periplanar. Try some more question. We have been given with H2O heat. So this first of all will be removed, will form a carbocation here. It is already a 3 degree carbocation. Next carbon to it. This one can give you least stable product. This hydrogen will give you the. In next way, this will removed out as H plus, and then alkene is formed. E1 elimination. Try this question. Now what is happening in this question? Just check it out. One of the chlorine is coming out of the plane of the ring. Another is going inwards of the plane. But most importantly, should give you anti-periplanar. So chlorine is there. This is the anti-periplanar. This is hydrogen. Attack will be happening over here. Leave like this. So I guess this is how the compound will be looking like. Benzene. If we have what? Not benzene, yaar. Anti-periplanar. No, this is not correct. This is not anti-periplanar. Try to understand, everyone. This will be having in the same planar which is not anti. See, same direction they are having. So these are not anti. In the similar way, this will be having like this. This will be having like this. So which hydrogen should I remove? None. Halogen and the adjacent hydrogen are in the same plane. So we cannot take this reaction. I think no product. No product. No E2 elimination will take place. It is not following the condition of anti-periplanar. It is not going in anti. Might be planar but not anti. Choose the correct statement about EI. Unimolecular and bimolecular, occasionally major product is all are correct. Yeah. We have a question back in JEE in 2019. NaOET is given to us. So this is a NaOET is a strong base, sodium ethoxide, and also called as alcoholic KOH. So this alcoholic KOH or alcoholic NaOH will do what? Elimination. So where is the? There it is. This hydrogen will leave this and then leaves the chlorine behind. What is the correct product you will get? CH3, C, H double bond C, CH3, C double bond O, O, C2H5. Now check it out. Okay, one mistake I made. This is CH3 and then directly doubly bonded. Like this. अरे नहीं यार. This is the carbon and this should be a doubly bonded carbon. CH3, we have CH double bond C, CH3, CH. Now even I am confused. Heat is given, so definitely it is E2 elimination. Strong base is given, but CH3, CH2, C double bond CH2, CH3, CH2. B is the correct answer. Okay. This is no idea, guys. This is the correct answer. Which I'm drawing is the correct answer. This might be some misconception. Okay. This is the same only which we are drawing. Take it from this side. CH3. Then we have CH, CH3, CH, double bond C, CH3. It is correct. B is correct. The only directions are different. Angle of watching it is different, but it is the same. Next question, JEE in 2016 has been asked. 2-chloro, 2-methyl pentane on reaction with sodium methoxide in methane yields what? Methanol. So this is elimination reaction only. So let us first write down the example what is given to us. 2-chloro, 2-methyl pentane. First write the word root, then put 2-chloro, then put 2-methyl pentane. Then we are having NaOET and we are heating it. So this is basically E2 elimination happening in the presence of strong base. So what does it do? It will go and attack on the beta. This is alpha, this is beta, this is also beta, but more stable alkene will coming out of this. This will come like this and Cl will be removed. Now check it out. So basically all of these products will come because why? Because this product will be the major ZF alkene and these two will be the minor. Because if both elimination and substitution product are given, yes, there could be a possibility a small fraction can go for elimination also, for substitution also. Majority of this can go for elimination. So this is how the respective products will be formed. This is correct. Next is the major product of the following reaction. HBr is the first we are attacking with. So in presence of HBr, what does it form? One where H will be added, another is where positive charge will be stable at which position? There it will not be. Probably here. Br. I have done the Marconi cause addition. Marconi cause addition, that wherever you get the more stable carbocation, there will form the Br. The next one is alcoholic KOH. So either it can eliminate both. It can eliminate both also. So how does it look like if both are removed? This will form like this. More acidic hydrogen is there. This is how it will form like this. And this is your double bond O. So guys, this is hydrogen here. And in presence of it tautomerize in its enol form. See, your correct answer will be a phenol. Because this is aromatic, this is more stable. D. Very good question, by the way. Then we have one more type of reaction called as even CV reaction. So this is called as unimolecular elimination reaction through conjugate base. Why does it happen? If we are using either a bulky base, preferably in the we are either using what? Presence of beta carbon has a keto or aldehydic group or ester nitro group which stabilizes an anion, then only this reaction can happen. Or in presence of poor leaving groups such as fluorine, OHCN, like that, and then preferably strong base will be used like this. Take this example. So this is not pretty much clear. Let me draw this example over here. We have chlorine, we have chlorine, we have hydrogen, we have carbon, we have fluorine, and we have fluorine. Guys, what do you think? Where should I attack with a base? So let us suppose we have been given with a base. So this is your alpha carbon, this will become a beta carbon. Why? Because base attacks only on hydrogen. This hydrogen leaves its density, electron density here, and then fluorine will not remove at one step. So what will be the intermediate? The intermediate ClC with a negative charge over here. Then we have Cl. We also have 3 fluorine here. This is called as conjugate base. So formed species called as a carbon ion, and carbon ion is also called as conjugate base. At last step, this will go like this, and this will remove out. Fluoride will come out, and then this will form C, Cl double bond C, FF. Chlorofluorocarbon is your product. Am I clear? So since this reaction is taking place in presence of a base, and also this is your even CV reaction, elimination through conjugate base, and conjugate base leaving group coming out of the carbon ion is called as the RDS here. This is the slow step only. That is why you can say this reaction is unimolecular. Even CV mechanism is the intermediate is the carbon ion. We all know. This is what you can do by your own. I'll directly make the product. And this process is even CV. Mechanism is even CV. Which of the following cannot give even CV reaction? So the one which will be having a not a good if there is not a poor leaving group, then even CV will not occur. Simply even E2 will occur. This is the correct answer. And only simply E2 it will give. Poor leaving group should be there. Even CV statement, formation of carbon ion correct. Electron withdrawing group facilitate the carbon ion and its stability correct. Leaving group even CV is poor correct. All of these are good. There is a question asked in JEE in 2024. So this question says that something is happening. What is the correct answer? Okay, I'll check. C2H5Br on reaction with alcoholic KOH will first form CH2 double bond CH2. On Br2 it will give you CH2Br. CH2Br. Excess of KCN will make CH2CN. CH2CN. Upon hydrolysis, not a double bond यार. खोया है खोया है खोया है खोया है चांद जैसे तारों में चमके जिसकी वो आँख मैं ही तो हूँ ना. आके तू सुनना नी ना 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 ना. So this is COH, CH2, CH2, COH. What do we call it? Ohm's gap. Succinic acid. गड्डी नी विच करा के पाई इंच ते पवा के टायर घूम दे ने तेरे शहर घूम दे. Next question, please. So guys, leave the questions and understand this part, that we are conducting a very big event very soon. And this event is gonna to happen live on 10th of December. And go to the YT channel JEE Nexus, where you can notify and you can get the live update of this very important event. And specifically this event is for you people, so I want you people to join us, enjoy, and find us enjoying the session also. So that is what. Now you people try this thing as a homework. There is one more good question. Try it as homework. And then we will come to the aryl halide. So now I'll be back. Allow me a moment after bringing some water for me, and then we'll start aryl halide, their preparation, their reactions and all. खोया है खोया Chalo, let's start now. Now we have preparations of aryl halide ARX. So guys, ARX are you all are aware of. This is your aryl halide. We also call it halobenzene. So how are we supposed to prepare aryl halide? So number one is with benzene. So with benzene it is very easy. Previous days I told you that we use reagent like X2 plus anhydrous FeX2 or FeX3. It forms a complex of FeX4 minus plus X positive, which is called as an electrophile. Now this electrophile can easily attack on benzene following EAS reaction, electrophilic aromatic substitution reaction. Electrophile comes, this attacks. Let's say this is electrophile, this is hydrogen, this is the positive charge. Hydrogen departs. This is called as electrophilic aromatic substitution reaction, where we are substituting hydrogen with an electrophile which is your X positive. So instead of E I must write X positive only. This is your halobenzene ready. Another reaction could be this. From benzene we already have covered. So guys, I2 we cannot conduct this reaction in presence of IO2 because HI is a very strong reducing agent and reduces iodobenzene to benzene. So that's why what we use is an oxidizing agent which can directly react with HI. So HiO4 or HNO3 are used, which converts H2O into I2, so that this doesn't interfere with the iodobenzene. Iodobenzene will be staying there as this. Next, from aromatic hydrocarbon. Aromatic hydrocarbons are like toluene. Toluene is being attacked by the same reagent, forming ortho and para. Why? Because I told you that electron donating or electron releasing group ERG in the terms of positive M group plus mesomeric group, they all are ortho para directing. So they create a negative charge density specifically on ortho and para position to the group they are attached on. So now on that positions an electrophile can come directly and attack. So this will give you ortho and para directed products. Then from benzene diazonium salts. What are diazonium salts? Benzene diazonium salt is made from aniline with the interaction of NaNO2 HCl, which is also called as HNO2 nitrous acid, freshly prepared acid. Otherwise it will stay in there and can disproportionate back into nitric acid and nitrogen oxide. So that is why it is actually freshly prepared, and then 0 to 5 degrees Celsius is the temperature maintained, and it gives a benzene diazonium chloride. Now this benzene diazonium chloride can be reacted. Okay, what we are preparing? Okay, halo. So this benzene diazonium chloride can react with Cu HCl and Cu HBr, copper powder, and this reaction is called as Gattermann reaction. Let me check. Okay, Gattermann reaction. Yeah, I told you, no, Gattermann reaction. So CuHCl, it gives you this product of chloro or bromobenzene, and if you use instead of CuCl or CuBr, if you use, then it gives you, it names it Sandmeyer reaction. The product will be the same, only similar mechanisms follow, only the names are different. Then by heating with Ki, if you heat your so prepared benzene diazonium chloride with Ki and under heat, it will give you iodobenzene. And if you react this with HBF4, then it forms N2BF4. On heating it gives you fluorobenzene, BF3 and nitrogen. This reaction is called as Ball-Schiemann reaction. Ball-Schiemann reaction. The product formed when benzene treated with Cl2 in presence of FeCl3. Benzene with this in dark, chlorobenzene with the product. NaNO2HCl, A will be your benzene diazonium chloride. On reaction with HCl, what reaction takes place with HCl? Yeah. Then on reaction with CuCl and HCl, it will form chlorobenzene. Then with the CH3CuCl and chlorobenzene is also there. So guys, chlorine itself is positive M in nature, creates a negative charge density on ortho and para respectively, will give you C double bond O CH3. This process or the reaction which we are using is called as Friedel-Crafts acylation. If you remember, Friedel-Crafts acylation, Friedel-Crafts alkylation. So this is acylation. Acyl group is C double bond O CH3. Toluene reacts with chlorine in presence of iron 3. I'm tired of this here. How many times should I? Toluene, ortho and para will give, and para will be the major. Then we have the reaction of toluene with Cl2 in presence of AlCl3. अरे यार homework यार, the similar question यार. एड टू HCl कॉपर ब्रोमाइड यार, बड़ा यार वेरी इजी यार क्वेश्चन यार. केमिस्ट्री सो इजी मैन. Sandmeyer reaction. Products, the Cl will remain Cl. Only this part will become what? Br. So these are some important reactions which I am writing. Please learn these reactions. These are very important. Next topic comes the chemical reactions of aryl halide ARX. The chemical reactions of aryl halide. How the aryl halide gives you these reactions. So guys, generally they do not undergo SN reactions because they have partial double bond character over there, and you must find this, that halogen atom present over here has a lone pair over it which works as a positive M group and can displace electron density like this. A negative charge present over here, X can acquire a positive charge, can shift electron density into this way. This will be moving like this, and then this is how it is formed. No charge is here, simple X, and a substituted double bond are formed. So guys, what you understand out of these all are called as the resonating structures, and these resonating, the structure will have a resonance hybrid looking like this, with a halogen and a partial. So this is called as partial double bond, and this bond is now stronger bond because it's a double bond, Earlier it was a single bond in alkyl halide. So that was removed very easily, that was broken down very easily. But now this bond cannot be easily broken down, and that's why reactivity of aryl halide decreases, especially in the terms of nucleophilic substitution. But yes, under harsh condition they can give you. So there are multiple reasons, please understand and read it out. Neither the phenylenedium carbocation is stable, nor that carbon X bond is easily breakable. Also, the electron nucleophile is negatively charged, and the negative charge of benzene, this pi electron cloud, repels that. So due to these reasons, they cannot attack easily upon. Nucleophilic substitution doesn't happen easily. But yes, it can happen under harsh conditions, under hard condition. The condition could be very high temperature and pressure. See, this process is called as Dawes process. This is elimination addition mechanism. So number one is called as elimination addition mechanism. So first elimination will happen, and then addition of the nucleophile will happen. So how do we carry out this reaction? So guys, initially we are taking a base. Base attacks directly on the beta hydrogen, as you all know, alpha, beta, and forming a very unstable intermediate called as benzene. This is your intermediate benzene. Now the next OH minus as a nucleophile can attack on either of the side, either on this one or on this one. So directly can attack on this side. So there will be a negative charge, and that will acquire hydrogen from somewhere. So followed by H. This is called as Sine substitution. Sine means the same side from which that was departed. Direct substitution. Okay, no. Direct substitution means Sine means another side. This is same side from which the elimination has happened. Elimination of halogen is occurring from that side, only from that side. If the attack takes place, it is called as direct addition. Others call it as a Sine addition. Hopefully this part is absolutely clear to all of you. Allow me a moment, everyone. Allow me a moment. So this is what it is happening on harsh conditions, not on the normal conditions. We have to use a strong base first of all, which is eliminating the hydrogen, and then also eliminating halogen atom with the preparation of benzene as intermediate. Although benzene is not aromatic in nature, and it is not very stable also. We cannot have any sp hybridized kind of carbon in this cycle, but on harsh conditions we prepare reaction goes like this. Then we have conditions for this SN reactions, and especially for what we are doing is, this is called as elimination addition reaction. First thing that we have to use is a strong base like RLI and NH2 minus, and then like this. Presence of beta hydrogen must be there. If beta hydrogen is not there, then you cannot eliminate out anything. Beta hydrogen must be there. See, there is no beta hydrogen, so there is no reaction. Take this example, everyone. Take this example. We have been given with NH2. We also have Cl here. The very first thing is happening. This is your alpha carbon. This is your beta. Beta hydrogen will be eliminated out at first. Chloride is eliminated, and then so formed is your benzene. Now from benzene, two side attack can be taken place like this. So the product will be and the another product could be direct addition. So direct will give you this. Like this. And stability of anion depends upon the inductive effect of the group G and not upon the mesomeric effect or hyperconjugation of the group G. So whatever group is there, so guys, benzene is there. So from where we are removing this, got it. The aryl halide do not undergo this why SN reactions, because the CNX is very strong, partial double bond character is there. Replacement of Cl of chlorobenzene to give phenol requires drastic condition, but chlorine 2,4 dinitro goes easily. Why? Because NO2 donates electron, very wrong. NO2 withdraws electron density, very good. NO2 make electron rich, no. NO2 withdraws electron density matter, no. It only withdraws from the orthopara positions and making orthopara positions electron deficient, so that a nucleophile can come and attack. Aryl halide are less reactive than nucleophilic due to all the reasons are correct, everyone. Please understand. Please read it out. This reaction is given to us, NaNH2 is attacking. What is the correct product that we'll get? Since it's a strong base, we all know what does a strong base do. So inductively it will work. You remember, inductive effect will take place. So initially what you do is, it is OCH3 and OCH3 applies minus I effect. We do not consider any hyperconjugation or any kind of mesomeric effect. So for the first step, this base will come. What is this base? NH2 minus. It will attack here and a carbon ion will be formed here. Now this carbon ion is getting stabilized by the OCH3 and its minus I effect. This forms benzene. This is your benzene. Next step, NH2 minus will come, attacking the both side, direct and sine. Both side can be the product formation take place. So if it is attacking on ortho, it is elimination. No, it is addition elimination. No, elimination addition. First is elimination addition. Or direct can also elimination addition. But major product will be from here because majorly it will stabilized. Let me check if any answer is given here. But yeah, B is the major product. Direct product will also be there, but major product will decide. Then benzyne intermediate is observed in. So where can you find the benzyne intermediate? Benzyne intermediate can be found in wherever there is a beta hydrogen. There is a beta hydrogen. There is a beta hydrogen. I think all of them are correct. Next is called as addition elimination reaction mechanism. So in addition elimination, what happens? Presence of electron withdrawing group at NO2 also helps this reaction. So guys, addition elimination, how does it take place? Please understand this. The halogen atom which is ortho at para with respect to electron withdrawing group is replaced. Halogen atom which is the ortho para with respect to electron withdrawing group is replaced. That means no idea. Directly proportional to the ability of aromatic nucleus, the one which causes the positive charge. More number of electron withdrawing group, faster is the rate of reaction. Attack of nucleophile, addition, and then electron deficient carbon is RDS. Okay, and then carbon is disrupted, the aromaticity, the ring departure of the leaving group elimination is fast, hence it regains its aromaticity. So this is how it takes place. OH minus attacking over here, then electron density shifts in such a way so guys, this is how it makes an RDS. This is how the RDS look like. So if ortho position and para position have this group NO2, then it is facilitating the rate of reaction. Similarly at para position, the attack takes place here. The electron density goes like this goes like this. And then finally, not at meta it is not possible. Meta there is no, as you can see, there is no transfer of electron that can take place. So this doesn't facilitate. Which of the following will show you faster rate of nucleophilic substitution reaction through addition elimination mechanism? So which one is having more number of electron withdrawing group? So 2,4 dinitro is good. Which of the following reaction is SNAR reaction? So SNAR reaction in which nucleophile attacks on the benzene or benzene substitute or benzene compound, and then removal of a group takes place. Now check it out. This is ARSN. So this is replacing this. 1 mole of ETO1 is there. Which one should be removed? So guys, I told you, if you attack over here, this so-called electron density will be stabilized by NO2 group such a way, and OET will be connected here. So correct answer should be this. Then we have RONA. Maximum for fluorine, because high will be the, if fluorine is there, higher minus charge, this will be higher plus charge. O minus attacks on this. Initially, electron density redistributes. How can you convert chlorobenzene directly into phenol? Phenol, chlorobenzene to phenol. So use chlorobenzene to phenol. NaOH is used with high temperature, high pressure, 623 Kelvin temperature, 300 atmosphere pressure. Process is called as Dawes process. Follows ARSN reaction. So guys, addition elimination reaction is ARSN2 reaction, and elimination addition reaction is ARSN1, because that is unimolecular, this is bimolecular. Then electrophilic aromatic substitution, one of the very easy reaction that we have already came across, and in previous chapter hydrocarbons I have already explained this part to you. So I'll give you a basic idea how does this reaction work. In these reactions, since halogen over here, it is orthopara directing in nature. That means electron density from here can be shifted to here. So wherever you can find a negative charge, by there only the reaction will take place. See, this negative charge comes here like this. Negative charge comes here like this. So where can you find the presence of negative charge where an electrophile can attack? I find this negative charge at two very interesting positions, ortho and para. So at last it will acquire the same conjugated one. Alternative double bonds have been changed their positions. This will become simply Higgs. So that's how it look like. So you can see that the negative charge is appearing on ortho and para position, and that is why we say that aryl halides are orthopara directive in nature. Rest everything is pretty much explained to you. Halogenation, nitration, sulfonation, Friedel-Crafts alkylation. I think this was not told to you, that I'll tell you right now. So Rx plus anhydrous AlCl3 will give you what? R positive plus AlCl4 negative. But the important part is this works as an electrophile. But again, take care that rearrangement is possible here. Rearrangement is possible. Then acylation, acyl group is RC double bond O Cl. If you are attacking with anhydrous AlCl3, then RC double bond O positive will be your electrophile. AlCl4 will be a complex. So the major product of sulfonation of benzene, major product of sulfonation of chlorobenzene, we can do it easily. This is your chlorosulfonation. SO3H will be connected here. Because of the steric reasons, 4-chlorosulfonic acid will be more stable. All activating groups are meta directing and ortho and para directing? No, nor meta, only ortho and para directing. Which of the following is an electrophilic substitution reaction? This reaction is SN. This reaction is ARSN. This reaction is correct. No. Minus charge is it is incorrect. But this is correct because this is working as an electrophile and substituting H positive. This is how the reaction works. D is the correct answer. Statement 1, that aryl halide undergo electrophilic substitution reaction less readily than benzene. True. Aryl halide gives only meta product with respect to no. False. So one is true, second is false. One is true, second is false. Because at the ortho and para position directed product we get the group present over there. If it is electron releasing group, then it will give you what? Ortho and para directing groups. Ortho para actively substituted product will begin. The electrophile used in the case of sulfonation is SO3 and chlorination is Cl positive. We have covered this part in previously. We have a question asked in JEE Main 2024. Identify the compound A and B. Br is there. We are attacking it with concentrated HNO3. So no doubt concentrated HNO3 will attack on ortho and para positions respectively, differently. And then in presence of NaOH and HCl, correct. A is the correct answer. Okay. So since we are using concentrated HNO3, it will be attacking on all the positions possible and this will form NO2 and then reaction of NaOH becomes very simple. And second, we are providing it H plus so that O minus it can become OH. Picric acid is our answer. This question was asked in JEE Main 2024. Now the last and final topic of the day, everyone. We'll go through very quickly once and then we'll wind up the session. We already have spent 4 hours, even more than that. I don't want to waste your time. I will quit the session from here. We have polyhalogen compound and sometimes their uses have been asked, not right now in the terms of JEE, but yes, it was earlier very important. We have polyhalogen compounds such as very important compound dichloromethane. Dichloromethane is CH2 Cl2. So what is this compound? It is used as a solvent. It is also used as a paint remover, propellant across the aerosols. It is also used in the solvent of manufacturing of drugs and it's a metal clearing and furnishing of solvent. Then we have toxicity of dichloromethane is what? The methyl chloride harms the human central nervous system. Exposure to the lower levels of the methyl chloride in air can cause you to lead slightly impaired hearing, hearing and vision. Then higher level of this can cause the dizziness, tingling and zoop. And humans direct, you read it by your own. We have chloroform used as an alkaloids, iodine, fats as a solvent and dissolve these compound. It also used in freon refrigerant R22. It is used as anesthetic in surgery. Risk is depressed the central nervous system, dizziness, fatigue, or the headache, cause damage in liver, kidney. Don't consume it again. And in presence of oxygen, it gives you a very harmful gas called as phosgene. So we are supposed to keep the chloroform always in the closed and dark container. We should not get it very open to the air. Then triiodomethane, iodoform is an antiseptic of the actionable smell, replaced by the formulation of iodine. Nice. This is some theory part. I personally prefer that you should all go through this and notes will be shared on the link given to you. Guys, this is some event which you are conducting. I'm again repeating that this conduction of the event will be happening on 10th of the coming month, which is just a day after tomorrow. So guys, please join this at the rate JEE Nexus. JEE Nexus. You can find the link, so do notify it and attend this event. And thank you everyone. Thanks for being so patient. There I end up with everything.